Hey everyone, I'm James,
And I'm Jamie.
and welcome to Azure Developers APIs in Action. We have an awesome day planned, don't we, Jamie?
Oh my gosh, it is jam-packed full of tons of amazing sessions, 16 sessions, I believe, to be exact, covering all things APIs from our API management team, discussing everything about a hybrid multi-cloud management platform across all environments. And then today we're going to learn specifically about API architectures, acceleration growth, how you can manage those APIs across clouds on premise, all for accelerating your business, improving API discoverability, and transforming your existing services. So I'm really excited to dive into all of this.
And there's so much. We have great speakers, like you said, from Microsoft, but also the vast community around APIs and APIM and all that goodness. Now, of course, don't want to forget if you're over here on the Azure Developers YouTube, don't forget to subscribe and follow so you stay up to date as we put out videos all the time right here on the channel, youtube.com/@Azure Developers for all those goodies. Like Jamie said, we have a full agenda lined up with all sorts of good stuff. We'll be coming back to this agenda slide, so don't worry about screenshotting and stuff like this. We have it all set up. We have awesome sessions, so many things going from here. And that's only the first 10 because we got 6 more coming down the line as well. So all sorts of topics like Jamie talked about, and we have tons of things happening. Before we get into the sessions today, let's hear from Mike from the APIM team telling you a little bit more of what you can expect from the day. Take it away, Mike.
Welcome to APIs in Action, a one-day event dedicated to empowering API developers and practitioners. My name is Mike Budzinski and I'm a Senior Product Manager for Azure API Management. Whether you are using Azure API Management or other tools, this event will help you learn how to better manage APIs throughout their lifecycle. This event is for anyone who's interested in APIs, from beginners to experts, from developers to managers, and from small businesses to large enterprises. You will hear from speakers who have diverse backgrounds and experiences in the world of APIs and who will share their insights and best practices. By attending the event, you will gain valuable knowledge that will help you in your everyday tasks related to APIs. You will learn how to design, test, secure, publish, monitor, and scale your APIs. You will also discover how to create innovative solutions by leveraging APIs, for example, in conjunction with AI services. We hope you enjoy the event and make the most out of this learning opportunity. Thank you for joining us today, and let's get started.
So great to hear directly from the team. Let's go ahead and get started with our first session of the day, the role of API management in Azure Integration Services. Take it away, Mike.
Hi, welcome to Azure Developers APIs in Action. In this session, we're going to talk about the role of API management within an Azure integration platform. My name is Mike Stevenson. I'm a 15-year Azure MVP. I'm based in Newcastle in the United Kingdom. The link there's for my blog, which people are welcome to check out if you'd like to learn about any of the content I write. My day job involves working with a company called Turbo360, who are a specialist in cloud monitoring and cost analysis on the Azure platform. If you'd like to learn more about sort of architecture topics around Azure integration, which a lot of them involve the role of API management and comparing different technologies, such as things like logic apps versus API management, I've got a YouTube playlist which is shown on the screen here. There's lots of good content in there, so please check that out if you'd like to learn more about that topic. So if we start thinking about the role of API management in an enterprise integration platform, so imagine that I'm an architect or an integration developer, and I'm trying to build a platform that'll implement lots of different interfaces connecting various systems across the organization. A good diagram that could describe our platform similar to this one shown on the screen here. So we have different capabilities that we require to build integration solutions, such as system workflow. We may have ETL and ELT patterns. We've got enterprise application integration, And some of the core areas that API management fits in this is shown in the API space and things like the helper function space. So there's a number of different use cases where API management can really help you with your integration platform development. And I think this diagram is a great way to show the relationships between the different technologies on the Azure platform. So for example, logic apps, functions, and API management can be combined together to produce a great integration solution. In the rest of the session, we're going to take a look at some example use cases and talk about how these technologies work together, and particularly focusing on the role of API management. So first off, let's imagine a scenario where we have an integration with SuccessFactors over here. So SuccessFactors is an HR system. In this case, we're publishing updates to employees. And over on the right-hand side, you can see we've got a number of target systems that care about different messages. So for example, an employee was a new hire, an employee had their details changed, they would go through to different systems. Now in this case, we've got technologies like logic apps and service bus shown here. So they would do that enterprise application integration, and we would do things like pub sub patterns, which would trigger different integrations. Now, when we think about the role of API management, you can see a couple of examples down here where API management would be used to help facilitate these integrations. So in this scenario here, I've got my person updates that go out to SAP and go to Salesforce, where I'm going to use API management to help me implement those integrations. If I'm a logic app developer for things like Oracle or SQL, we might have built-in connectors that talk directly to those databases. But when we talk to an API, a great thing to do is use API management to help centralize that all of your APIs. So that gives you a single place where you can manage, change them, provide monitoring and security features to get that centralized governance of your use of APIs. And from logic apps, you would have the API management connector that would help implement this sort of connectivity piece from a logic app, in this case to SAP over here. Now, some of the good things you can do in this pattern, so I would refer to this as an outbound API if I was looking at it from the perspective of an integration developer. So from my integration platform, the direction of these operations is to go from the platform to a third-party system. So in this case, I can centralize the use of things like security for how I connect to SAP. I can centralize the monitoring. I can centralize any kind of mapping capability that might be reused across multiple integrations. And the key thing from that centralization is on my integration platform, I'm probably building lots of integrations that talk to SAP beyond just a simple person upsert. There may be other integrations around employees or other use cases. I can reuse the proxy APIs that are built to sit in front of SAP. And API management's role is really about making the integration simpler and providing those reusable services. So that would be what I'd class as an outbound API. The next one we have is one I would class as an inbound API. So this is where inside my organization, I've got some line of business system down here, and I've got maybe a logic app or some other technology like a function where I've created an integration on top of that application. So let's pretend this line of business application has some kind of database connector, and I want to be able to expose that as an API to other systems. So if we're allowing our systems to integrate with an API first approach, that makes the integrations that we build become more reusable. So in this case, I've chosen to sit API management in front of this logic app rather than have the end systems call a logic app directly. That opens up a lot of really good things. So here, let's imagine in this case, I've got a system of engagement such as a Power App, where I can create the ability for that Power App to go through API management and reuse that logic app. But I may also start ending up having other apps that I build. So maybe I've got 2 other apps we build, and they can talk to the same API, and reuse the integration that I built, but I can give them different security keys, or I could configure different ways that the authentication or the rate limiting would work. A good example actually is the rate limiting, where if I build more APIs on top of this system, I can control how much each application might use it. So in this scenario where I call that an inbound API, I'm really thinking that these applications are inside my organizational boundary. They're internal apps we build, and our API management's used to connect them to other systems in the organization. The next pattern we have is what I'd class as an external API. So if you really notice this definition of the organizational boundary here, so in this case, I've got a scenario where I've got trains that travel around the country. We have telemetry events come from these trains. They come through a third party. So if we imagine on the diagram, there's actually a third party who collects those messages and then forwards them to our organization. So here we're having API management sat at the edge of our organization. We can expose an API out to that third party. And then what we might do is we need a back end for this API. And in this case, you can imagine the events we get from our rail cars, we're going to send them to multiple different systems. So if we look over on the right-hand side here, we've got an application database who needs to know about early delivery of rail cars. We've got a customer system here that needs to know about where's the current status of a rail car for the order associated with that customer. And here we've got a data platform where we've built Power BI reports on top of Synapse, and we need to do data analytics of these railcar events. So in order to get to all of these integrations, API management over here is sitting in front of a function that provides some back-end logic such as validation, transformation of the data, and then this message gets dropped onto Service Bus, and that can pub sub for our different integrations through Logic Apps. Coming back to API management, the real benefits here are, again, things like the security keys or the security token validation. We can encapsulate that in API management to expose that API to more than just one party. So maybe, in certain APIs, you might have hundreds of different people who call it. But we can also do things like rate limiting. We're centralizing the management and monitoring of the API. We can perform some basic transformation operations if we want. And API management's a great way to expose that API outside the organization boundary. We may even choose to combine other technologies on Azure. So a common one might be that, let's imagine you put front door, you might put that in front of API management as well. And this really shows kind of the building block approach that Azure provides. You can choose the right building blocks and connect them together to implement your solution that meets your requirements. Next up, we've got utility APIs. And I think, again, this is maybe a bit of an underutilized benefit of API management. So in this case, I've got data from a plant coming through an integration inside my platform. So remember that my integration platform has hundreds of interfaces in it. This is just 2 or 3 of them. I've got my events coming from the plant. They pub sub through Service Bus here, and they trigger different integrations going to different target systems on the right. One of the things in this case, I've got a message about a rail car getting loaded and leaving the plant, and I need to do things like conversion logic. So one of the challenges I always find with Azure is if I want to just do some really simple logic, like in this case, I want to do like a weight conversion from pounds to kilos. I want to do a really basic validation function. Having to spin up a function app every single time for each new use case can be quite overwhelming in terms of the amount of function apps you would end up with. But you can quite easily build a conversion API in API management, and you could encapsulate all of that common logic inside the API. So I can, in this case, I can even just use a policy that just does a little bit of C# code in the policy to do that conversion and return the value from pounds to kilos. Then I've got a single API that all of my different integrations that need that conversion logic can share that API. Now, if that logic started getting more complex, maybe I sit a function app behind it and that could be the back end for the function if I needed more complicated code that required complex C#. But creating those common utility APIs that encapsulate logic, lots of my integrations are going to need a really good use case for API management as well. Now, if we think what this means, then in my integration platform, we look through a number of different use cases there of different ways I'm using API management. But really what it boils down to is in my integration platform, data coming in can come in through either connectors from logic apps, and it can come in through API management if we're exposing an API operation to another application or a third party. Once I'm inside my integration platform, I'm tending to use things like event grids, logic apps, functions, service buses, doing the internal processing in my platform. And then as I go out from the platform to other applications, again, I'm back to using connectors and logic apps for certain operations, so things like those database connectors, or if there's an out-of-the-box connector for a given application. And then where there isn't a connector and I need to use HTTP-based APIs, that's again where API management plays a role. And between these two cases here, I'm creating centralization for the management and monitoring of all of my APIs coming inbound and outbound from my enterprise integration platform. Thank you for listening to today's session. I hope you enjoyed this talk about the role of API management within an Azure integration platform.
All right, we are just getting started on APIs in action. Now, don't forget, if you're over here on YouTube, that you jam that subscribe button and hit that notification bell so you get up to date every time we put out videos right here on the Azure Developers channel. All right, next up is Tom with API management for microservices in a hybrid and a multi-cloud world. Take it away, Tom.
Hello, everybody. My name is Tom Karkove, and I am a senior software engineer in the Azure API Management team. And I am here to talk about how you can use API management for microservices in a hybrid and multi-cloud world. In the cloud, we have Azure API Management, which is a platform as a service for managing your APIs that has three main components: the management plane, the gateway, and the developer portal. In this scenario, all the clients will send their requests to the gateway, which is running in the cloud, which then forwards these requests to the effective backends. These backends can be running in the cloud or somewhere else, so then the requests go outside of Azure to those destinations, which means there needs to be a network connectivity, security needs to be in place, etc., etc. For some customers, however, this is a problem because they cannot send these requests outside of Azure. They cannot open public endpoints to their on-premise services, etc. Or maybe you just want to run this gateway in your Kubernetes cluster, for example. So to solve that problem, Azure API Management has a self-hosted gateway that basically brings the Azure API Management gateway to anywhere. You can run it on your local machine, on-prem, Kubernetes cluster, or even on a ship if you want to. So instead of sending all the requests to the cloud, you can basically run your gateway on your Kubernetes cluster in another cloud. You can run it on Docker Swarm, Docker Compose, or on-premises next to your on-prem applications. You can also obviously run it in Azure on Kubernetes or any container host so that the gateway runs close to your applications. However, there is one caveat. That gateway needs to have cloud connectivity, which is an outbound connection to get the configuration because it uses a cloud control plane. But basically, you can bring the heart of Azure API management where you need it. As I mentioned, it is a Docker container, which is Linux-based and is available in the Microsoft Container Registry. It is an equivalent of the managed gateway. There are some caveats or some features that are in the self-hosted and not in managed, which I will come back to later, but you can find all of this in our documentation. It is a federated solution, as I mentioned, so you need to connect it to the cloud to get the configuration. But if you lose the connectivity, the gateway will still run. Even after days, it will still run. So it is not that you are forced to have that connection. It is just that you will run an outdated version. Because it is a container, it's very simple to get it running, to try. You can also use it in your inner loop to test APIs going through API management, etc., etc. But let's use a demo where I will show you how easy it is to use the self-hosted gateway to spin up the gateway and serve your APIs locally. So in this case, I have here a container running, which is my Bacon API, which is exposing ports on my local machine. So if I use Postman, I can send requests to the service, and you can see I get 5 different flavors of bacon back. Very complex API. So what we'll do now is we will deploy the self-hosted gateway on my machine, and we will send the requests to it, which will then be forwarded to this Docker image on my machine. So for starters, I will go to my API management instance, and you can do this. You can use self-hosted gateway in the developer SKU or premium SKU. And on the left, you can scroll down to what is called gateways. So these gateways are basically self-hosted gateways that you can deploy. And I pre-created this APIs in action gateway. And you can see I did some testing this morning where you can see the metrics for this gateway, how many requests were sent, how long did the backend take, basically the same metrics you get for the managed gateway. You can find here a link to the configuration API that is used for the gateway to get the configuration. And in this deploy tab, you can basically see how to connect. So for example, you can use the Docker, Kubernetes, or Helm scripts to get started and get your gateway up and running. So in my case, I will use Docker, and the important piece here is that you will add the endpoint of the configuration API as a variable, and then we will use the gateway token authentication to connect to the cloud. You can also use Entra authentication if you want, but for the sake of demo, I will use this configuration here. So I have a local file with these environment variables, and I will now start the self-hosted gateway locally. So I will use some port forwarding. I give it a name. I add it to my local Docker network. I pass it with the environments that I copied, and then I am using the latest version of the gateway. So when I enter, this gateway is now starting up. And you can see the logs of this gateway. It is basically starting up, and now the tenant has started, which means it's ready to receive requests. So first of all, in the cloud, you need to define which APIs need to be exposed. So in this case, I want to expose the Bacon API. I click select, and this API is now allowed to be called. When I go back to the gateway, you can see that eventually this one will receive the change from the cloud because it is polling for changes, and it now has exposed the Bacon API on the gateway. So when I go to Postman and I now send a request to this self-hosted gateway for the same URI as the cloud, and I add my subscription key, I can now send a request and get the same Bacon back. If we go back to the logs here, we will also see what the gateway does and also see that it logged the request. You see here that the original endpoint that I called was this one. And then the backend URL was this one, which is the endpoint of the Bacon API on my machine. So very simple demo. You can deploy self-hosted gateway. You can expose a REST API, but basically it supports multiple. So we support SOAP, WebSockets, GraphQL, and this is an example of a difference. Self-hosted gateway also supports gRPC APIs, which is not supported in the cloud gateway today. So let's have a look at that. So I have here a proto file, which is used for gRPC services, also to get bacon, which you can use in API management. So if I go to APIs, you can select gRPC here, and you can upload your schema. You can then fill in the server URL, etc., which I have already done, which then eventually gives you a gRPC API with my operation here. So I have here also a .NET app that is basically a gRPC client which will use the self-hosted gateway running locally on port 8801. And because I'm running locally, I will allow insecure server certificate. And then I basically imported the proto spec, and I am creating a bacon client based on that proto spec. I'm also adding my subscription key, and I am requesting bacon through the generated client, which I will now run. So what will happen is it will send 10 requests, and those 10 requests, let me zoom that a bit. So those 10 requests will be sent to the self-hosted gateway by using gRPC. Oops. So if we go to the logs here, we can also see that we're calling this gRPC endpoint and that we are using HTTP2, which is used by gRPC. So also very simple, import protospec, allow it to be exposed on the self-hosted gateway, and you can just consume it. But there's more. On gRPC APIs, you can also apply policies like any other. So for example, I've sent 10 requests, but let's imagine we want to apply rate limiting. I can just apply the same policy. So I can go back here and apply the policy to rate limit and only allow 5 calls in 5 seconds. So let me save that. And then in the logs, you will also see this change being reflected. So here you see that on this API, the policy was applied. So in this case, we saw that we had 10 successful requests. If we run the same app now, we will also see again that we are able to use gRPC as a communication, but the gateway will basically start throttling your requests. So same experience for defining APIs, same experience for defining policies, but now with gRPC as well. We support all communication types, bidirectional, not bidirectional. We support all of them. And that's it. So easily run the gateway locally, expose all these API types, and serve the traffic to your local applications. So let's go back to the slides and have a look at some of the scenarios that customers are using. Of course, this comes with a shared responsibility. We offer this configuration API and the gateway, but in the end, this is a self-hosted gateway, which means you are responsible for things as well. For starters, we are a managed service. We offer an SLA, which includes the configuration API and the ability for you to monitor in the cloud. So in the portal, which I did not show, you can also see how many connected gateways you have, what the heartbeats are, etc. And of course, we patch bugs for the gateway and also give you security patches, etc. However, for customers, it is up to you to host the gateway properly, to operate it, make sure your network is properly configured, and also have the line of sight with the cloud for the connectivity. And while we offer new versions of the gateway, it is also up to customers to make sure they run on the latest version, have those security patches, etc. So to look at some of the common scenarios, we see customers use the cloud gateway of API management in front of AKS workloads, which means those AKS workloads need to be exposed. For example, could be with load balancers or other ingresses. But with the self-hosted gateway, you can basically change that and run our gateway with all of its features and API management capabilities inside your cluster and use it as your central point of communication, but also use that for service-to-service communication so you can decouple them. This can be important for example, if you have migrations and you have on-premise services you want to migrate off of, you can put our API gateway in front and use that as an abstraction layer so that once you start introducing your next generation services, you can start load balancing that traffic to eventually remove that legacy system. And of course, Azure Container Apps is a very nice service, a platform as a service for containers. There also you can use API management inside your inside the app environment as in public ingress, and then distribute the requests to your applications. And it also works with Dapper. So if you use Dapper on Azure Container Apps, you can also use policies to interact with these. So to summarize, why do customers use self-hosted gateways? There's a variety of reasons, but I tried to summarize them in four pieces. First of all, multi-cloud scenarios and run anywhere, where customers cannot always use the cloud, or they want to use multiple clouds. They can now use a unified management and operational experience, but bring the gateway closer to where it needs to run. Second is Kubernetes. Some companies basically standardize on Kubernetes, so everything needs to be deployed on Kubernetes or running inside of Kubernetes. But also, if all the applications run inside a Kubernetes cluster, why send all the traffic outside the cluster to bring it back in? Instead, you can bring the gateway to that cluster so that you do not have to open up any endpoints in your cluster. Some customers like platform as a service, but they cannot always use it because they need more flexibility and control. They want to be in charge of when are we upgrading the gateway. We want to have our own auto-scaling, local connectivity to the backend, etc., etc. You have more control, but you also have more responsibilities to take care of. And then lastly, self-hosted gateway offers more cloud-native capabilities as well. So we just saw the public preview of gRPC. It also supports HTTP2 end-to-end, so both for clients and backends, Dapper integration, open telemetry metrics, and more. And if you go to this aka.ms link, you can basically see a nice comparison between self-hosted gateway, managed gateway, and our consumption gateway, and how they are different from each other and how much overlap there is as well. So we strive to have like a full parity, but that is not always possible. So thank you very much for joining. I hope you've learned how you can use self-hosted gateway and bring the gateway anywhere, and hope to hear you use it and how we can improve. Thank you.
What a fantastic session. I'm already learning so much. But as we said, we have a full packed agenda. So let's go ahead and get started with our next session, leveraging API management for OpenAI applications with Elena and Chris.
Hello, everyone. My name is Chris Ayers. I work on the Fast Track for Azure team here at Microsoft, helping customers deploy onto Azure. And today we're going to be talking about leveraging API management for OpenAI applications. And I'm joined by Elena, if you want to introduce yourself.
And Елена Нерославская. I'm customer success cloud solution architect specializing on bringing Gen AI solutions to customers.
Excellent. So I'm just so happy everyone's able to join us and we get to talk about this cool stuff. So today we're going to start with just a little bit of overview of some terms around the OpenAI service, just a high-level overview of some of the issues that you're going to face potentially with tokens and rate limiting. Then we're going to talk about APIM and some of the capabilities of the API management service that we're going to leverage in our solutions. With some demos and some blog posts that might help you implement those solutions to scale your API management. And then Elena is going to dive deep into security and how we can lock down those solutions with identity and private networking and stuff. So I think there's a lot of cool things that we're going to get to talk about today. Well, let's get started. So OpenAI terms, just as we go through this, as we're going to start looking at some of the things, understanding tokens. And tokens are not individual words or letters. They're just kind of units of text that are processed by OpenAI and Azure OpenAI and the models. And these are a measure of kind of the input and output of the system. And that's how you have quota and how you have billing. And so quota is really just that maximum amount of like requests or tokens you can use at a given time. Like if you have so many tokens per minute or so many requests per minute. And we'll talk about that in a little bit more detail. Another term that's very important to understand is the model. So we have a lot of different models. GPT-3 was a huge ground-changing model. We've got GPT-4. There's GPT-4 with vision, and we also have some different ones that are used for like text embeddings, and text embeddings are used for searching and indexing your own data. So these are all very important things to keep in mind because we're gonna touch on them a little bit deeper in a little bit. API keys. So just like we secure our APIs, OpenAI secures its APIs through either something like a managed identity or a specific API key that you have to attach to your requests. And Elena, I think you're gonna go into some of that in depth, right?
Oh yeah, API keys are my favorite security measure.
Oh, I'm sure they are. Just embedded in an application that you can kind of look at and go, huh, that'd be fun. Rate limiting. So when we are using the applications, we start scaling, and we're starting to use more and more words, more tokens, we have more users and additional requests, we'll sometimes get rate limited. And so we might start seeing some weird HTTP requests with a 429. So 429 is usually the status code HTTP uses for rate limiting to tell you need to slow down or wait another minute to try your request. And finally, with OpenAI and the Azure OpenAI service, there's a couple of different deployment models for billing. There's just the pay-as-you-go, where you can use as much as you want, but it's kind of a shared service. So you might have to be trying to use that service at the same time other people are trying to use that service, and that can induce latencies that you might not be expecting. And then the other option is PTUs, or provision throughput units, where you actually are paying for a certain amount of capability and quantity, and that way you can kind of have that guaranteed capacity that you need for your enterprise applications. So now, just kind of digging a little deeper into tokens, this is an example of how different text, so those prompts that you asked the GPT model, the histories, the requests you get back are broken into tokens. And a token is usually about 4 characters. So in a given 75-word paragraph, it might be about 100 tokens. And highlighted in different colors are how the tokens in this example are split up. And that's why we use different services to keep track of tokens, and we try to optimize these at times. Like I said, quotas. Quotas are more of a touchy subject with a lot of customers because you can only get so much on the pay-go, and that's why we talk about the PTU model. But quotas are going to be not only specific to your subscription, but region. So in a given region, if you do like a GPT-3 model, it doesn't matter if you have 5 or 6 deployments of GTP3 in East US2, for instance, they're all going to share that same quota. So you're not going to be able to get additional requests just by spinning up another copy of GPT-3 in East 2. It's tied to your subscription in your region. So in a lot of cases, when you want to start growing your application and taking more tokens, you need to look at using other models or looking at other regions. And so now we start getting into that place where we need to start thinking about load balancing or having requests routed amongst different instances. Like I said, we grow our requests, we grow the complexity of the task we're doing, more data, more messages, and so we're going to start hitting those token limits. A lot of these might be measured in 10,000 tokens per minute or tokens per hour. And so if you're using 5,000 in the first 10 or 20 seconds, you might start to get throttled. So there is a conversion metric about like requests per minute that you get, but also, if you have 6,000 tokens per minute, that's probably about 1,000 every 10 seconds, but you can get throttled if you use 20,000 or 30,000 in the first 10 seconds. So this is where the problem arises for so many of our enterprise customers. Elena, I know you and I chatted about this before. Like, this is one of the biggest complaints customers have. Like, they start getting rate limited as they start scaling up. They're like, how do I solve this problem?
Favorite 429 error. Everybody complains about it. Yes.
Everybody. So API management comes to the rescue. We do have some other solutions, but I'm a huge fan of API management for this. Not only do we have like organizations that provide APIs for their customers, and they use like the developer portal, and they can do different authentication mechanisms. It does rewriting, and we have policies where we can kind of integrate JSON or XML or whatever behind the scenes and adjust paths and all sorts of stuff. And so by leveraging APIM, we kind of abstract away the APIs behind it and allow us good monitoring and security on top of our current APIs. And so we have a couple of solutions different teams have built. So, and they leverage these policies. This lets us transform those APIs. This lets us kind of not only provide our own rate limits. Let's say we put out a client and we're getting spammed by 20,000 requests every second just trying to hit the chat models. Well, we can rate limit them to more reasonable levels. We can authenticate and authorize them. For some of our APIs, we might cache. And so leveraging these capabilities, we've implemented a couple of solutions to support those API backends. And this is where for each backend will be a different OpenAI deployment or instance that we can route traffic to. There's a couple of new features coming as well that I'm going to talk about that have recently rolled out or in preview in APIM that really enhance these capabilities. One of the first solutions that actually one of my coworkers wrote, Andre Dews, he wrote a solution using policies to do prioritized backends. So in a given region, let's say in the East region, I want to have a PTU and a pay-as-you-go model. I can leverage those as long as I want until I hit that 429, and then I might route my traffic to something on the West Coast that's still a valid model and lets me expand my capabilities, but it's not the desired one. And it will pick up that 429 message that comes back from the OpenAI service and tells you retry after 12 seconds, retry after a minute, and it'll automatically kind of mark those as not usable for that 12-second window. And then as soon as it's back up, it'll switch back to that priority one model. I'm going to show this in a second. Another pattern, and this is where we're coming into some of the preview services, is they've expanded some of the capabilities of the policies to allow things like a circuit breaker pattern, where you can now define a backend pool of 3 or 4 different API services and say, when you see a 429, that's the thing that is going to trigger the circuit breaker. That's the thing that's going to stop you sending traffic to it. And then you can put them all in there. This doesn't give you that same level of prioritization, but it will just kind of load balance across them with that circuit breaker pattern. So it's a really good capability, and I'll be able to share that link hopefully later. So let's just quickly look at what this looks like. I've got on my screen some code here, and this is just a very basic Python sample where I'm leveraging one of those solutions we talked about. I'm going to use APIM, API Management, to sit in front of all of my OpenAI instances, and I can just call it like I normally would, where I'm going to be using API Management, I'm going to be using the subscription keys and call OpenAI just like I normally would. And I can, call my APIM and I can get the response back from OpenAI just like I normally would. This is part of that Azure OpenAI load balance sample. Let me actually bring up the Azure portal. This is where it's deployed 3 different instances and 3 different regions across the United States. And if I look at my API management, I've defined each of those as a backend. So these are 3 different backends that are going to be leveraged by the policy. And I've got an API here for OpenAI, and I can test this. I'm going to use a deployment of chat, and let me quickly get my API version. I always forget it, so I'm cheating a little bit. And we can just send this little test message, and we can see 200. We're getting a response back from East 2, and I can send it again, and now I'm getting North Central. So just by leveraging some of the policies, I can see my rate limiting, my request limits, my token limits, and I can have it automatically balanced between multiple instances that I've configured at a really, really low level. Now, this solution is out in Azure Samples as OpenAI APIM load balancer, and we've got documentation on how to manually deploy it with AZD. So this is a cool way to get started and play with this type of solution and scale horizontally across multiple instances. The same team also worked on providing a container app load balancer using YARP and .NET. It's another really cool solution where you can actually click a button to deploy it, fill in a couple of endpoints, and have it load balance across that. So we've got some really cool capabilities, and I know we already touched on that circuit breaker, where we can leverage the circuit breaker capability to do rate limiting across the 429s. So APIM is so flexible. The API management lets us not only not share all of our secrets with our customers, because I don't know what the access keys are for OpenAI in this deployment. This is a managed instance. So managed identity, my API management is allowed to talk to my OpenAI, and they talk without having a secret or a key because they're authorized to talk in the cloud. They have the rights and roles to talk to it securely. I have to have a key or an identity or some way to talk to API management to do that effectively. And I'm going to talk about all that security and hand it over to Elena, but some of these things are all found in a AI in the box solution. This is a solution that a lot of fast track members and CSAs and other engineers inside Microsoft have contributed to, where we have solutions around MLOps and Edge and these APIM solutions. And we have some guidance around responsible AI and some guidance around security for these generative AI solutions. All of the different attack vectors that could come in while you're leveraging these large models, and APIM helps lock that down. And so I'd like to turn it back over to Elena to keep talking about that security aspect.
Thank you, Chris. So now that we've seen how to improve scalability, right, with smart load balancing, we improve scalability and quota problems. Right? Now let's take a look. How do we put it now in production? Any deployment of application to production requires security. And thank you, Chris, for highlighting this repo, as I would like to show actually show this awesome GenAI security page that team put together with all the links. It summarizes many attack vectors. It shows OWASP top 10 for large language model applications potential risks. LLM apps are now embedded in almost every application in our work and even personal lives. And there are new challenges coming with that. And we also highlight here security strategies that help mitigate all these risk factors. So one of them is, I think, very important one is architecture strategies. We have number of blueprints and reference architectures that actually help secure and build scalable and available environment. And you could see all these links. What is even better, my favorite, they come with bicep files that actually all the bicep scripts to provision for you all the architecture with private networks, private endpoints, all this heavy lifting is done in these baseline architectures. Aspects that we also need to kind of concentrate a lot with our enterprise customers specifically, and any customers really, is network strategies, right? Where we have to look at proper network segmentation and make sure all our interactions with OpenAI, with any other cognitive services, always goes through our internal private networks and never leaves into open internet, let's say, right? And for that, we also have a lot of in-a-box solutions. But what I wanted to show you is one of the most popular ones, one of most popular blueprint architectures that you could see here. It's coming from our architecture center. And it basically provides a very comprehensive solution for centralized logging, auditing, monitoring, and also secure authentication of the incoming traffic into our LLM apps. Everything is deployed in our private network. The only single entry point, which is kind of internet facing, is on application gateway, which forwards traffic to our internal network with API management being cornerstone of the solution. It basically does all this smart load balancing that Chris was showing to different OpenAI instances to increase quotas, high availability, etc. But it also responsible for centralized logging. So all traffic could be logged and audited as it goes. It also is providing authentication and authorization of all the incoming tokens and identities that are trying to invoke our OpenAI LLM apps. And if I zoom in a little bit on the networking aspect, we see that API management, which is VNet integrated and internal and all these goodies, also connects to virtual networks and private endpoints of our OpenAI instances. So everything, all the traffic goes through private networks, as well as to other services that are supporting API management. You might use Key Vault, storage accounts that stores some additional information. So everything is secured, and all communication is enabled with our Azure Active Directory, or Entra ID, as we renamed it, and managed identities for any airbag control. And that's one of the next mitigation strategies that we have, is although we do tend to use API keys in our POCs, demos, we all did that, right? But in production kind of scenario, we would like to go totally keyless or passwordless, right? And offload all the identity and authentication to Microsoft Entra ID, Azure ID in the past, where everything is communicated through tokens, right? In this scenario, client application, and typically when we deal with LLM apps and GenAI, there are many frameworks that actually developers love and use, such as LangChain, semantic kernel, and so on. So this application in that case would authenticate the user, obtain token from Azure ID and ID, and pass this token for authentication to API management, and subsequently APIM management could invoke OpenAI. So what happens in this scenario, there are a couple of possible options where token that we obtain is token to authenticate to API management, and API management would embed managed identity of itself when communicating to OpenAIs. Right? In this case, API management is kind of main infrastructure point that validates your tokens, validates their claims, their signatures, audiences, and all that, and making decision if to accept or reject traffic, and forwards the requests. In some other cases, we've seen the need where application needs to pass token all the way throughout, where API management is kind of transparent proxy. It still validates the token, but instead of embedding managed identity, it passes it all the way to OpenAI. But it still acts as control gate for validating your tokens. So how do we do that? Let's see how we do it in code, because that's where typically is the most fun is. So let's start from bare bone HTTP communication. So first thing that we need to do is, of course, getting the token. Any application, any framework would do it behind the scenes for you. But just to see how it's typically done, we do typically have specific calls, how we obtain access token from Microsoft Entra ID. What is important here to note is your actual audience, right? Where your request is targeted for. So in this case, we target our audience to be API management gateway, and we get the token for it. And once we got the token, we embed it in our typical authorization header, right? And we could send request with our typical OpenAI chat completion API, as you could see here, OpenAI deployments chat with proper version, and receive a response similar to what Chris have shown you. So we get the response, and I could see which actual backend it hit in the API management. So if I iterate over them, there is good probability I'll get different ones. So here is different backends that load balanced by APIM, but having this authorization token in the mixture. So how we secured it, what I haven't shown you, the magic source here is that inside IPIM, what we added to the typical smart load balancing policy, we added policy to validate JOT tokens, validate these authentication identity tokens that are incoming. We see here the same audience that we use to obtain the token, and we validate additional required claims, issues, signatures, and whatnot. So it's very simple policy in IPIM to enable it. And that's all good with HTTP, but what if you have frameworks that you need to use, how to do that? So typically, as Chris was also showing you, we use typical Python OpenAI kind of constructs where we pass the keys, which preferably we shouldn't use, and we should use the token that I showed you. So how do we do that? We typically use a very standard Azure package with identity options in it, and we could obtain token. As you could see here, we obtaining token default Azure credential for the same audience that I showed you that is configured to be validated by IPIM. And now that I invoke the same call with this token, you see here Azure AD token provider, it's by itself behind the scenes does what I showed you in pure HTTP. It gets token with proper audiences from Microsoft Entra, and we now embed it in our communication, and we could, as usual, as typical, invoke all the client APIs. That's a bare bone token, Python API. In LangChain, which is extremely popular, they added the new option that you could see here. Typically, you would use OpenAI API type Azure when you invoke Azure OpenAI. Azure AD new type that allows you to pass actual tokens instead of keys, right? So that's how you actually specify to LangChain. And instead of API key, you actually get the token with proper audiences as usual, but you actually get token, not API key. Nothing is hard-coded here. And then, as usual, you could start invoking our chat completions API in a very similar manner as before. And you see here that it created the completion.
That's
So
really cool. I definitely need to go and update all my samples to use the tokens now.
Yeah, thank you, Chris. And that's exactly what I wanted to ask our listeners to do. Try to kind of remove your API keys, try to use tokens, especially if you are doing GitHub integration. We all accidentally sometimes put our API keys there, so be careful with that. Yeah, that's very simple, really. All frameworks now support it. Previously, it wasn't there, but right now, everything is supporting AD tokens, LangChain, semantic kernel, barebone OpenAI. So just do it.
Awesome. I think we had one or two more resources we wanted to share.
Yep. And let me just talk quickly about this awesome blog from Clemens, who actually pointed out that routing patterns sometimes we are using not only for load balancing, but also for cost and error handling. So some of our prompts tend to grow very big. They might become more than 32K tokens or get very lengthy. So there is ability to do it on APIM or LangChain itself to actually fall back to bigger models, larger models, if you get big prompts and big completions. So we definitely read that, how to do that. It's very good pattern, also saving you cost because smaller models cost less. So you could use smaller typically and just fall back to bigger when you have really big text to complete. And with that, I think we could thank you, all our listeners, and ask them to secure everything and have fun with LangChain and APIM and load balancing and increase your quota by load balancing.
Thank you so much. That very educational, got a lot of good resources. We'll try to make sure we share all that. So thank you guys for joining us.
I love hearing about OpenAI and all the amazing things that you can do and how Azure API Management helps out there, which is so cool. But we got more sessions on the way for APIs in action. Next up is Azure API Management from a developer's perspective with Tune. Take it away, Tune.
Hey there, thanks for tuning in on this session about Azure API Management, but from a developer perspective. My name is Tom van Houten, I'm from Belgium. I'm the CTO at Noost. With Noost, we want to make people's lives easier and more efficient. And we do that with crafting solutions, end-to-end solutions on the Microsoft stack. We do that with a local community in the west of Flanders in Belgium, and we try to make from there a global impact. I've been awarded as an Azure MVP for the last 6 years, mostly thanks to my contributions in the Azure integration space, of which Azure API Management, of course, is a fundamental part. All right, before diving into the developer experience of Azure API Management, let's take a step back and let's have a look on why API Management is used within organizations. So API Management is typically sitting between your API consumers here on the top and your own backend APIs that you own yourself. So the consumers can be scattered around different networks, on premises, different clouds available, and also over the internet with external parties. On premises, you have your own APIs, probably also in one or multiple clouds, and also external APIs like SaaS products that you don't own yourself. Then API management, what is it doing there in the middle? One of the most important things is adding a security layer It makes sure that all the different authentication mechanisms of your backend API, that they are consolidated in one unified authentication experience for your API consumers. You can route APIs and merge multiple APIs into unified APIs. And you can also transform APIs. And so consider, for example, a SOAP API. You can, with Azure API Management, expose that to your own API consumer in a RESTful manner. You can do optimizations in the API management layer by adding, for example, caching. And we need to invest there in monitoring. You will see that a lot of monitoring happens out of the box. So you have a good view on how your APIs are doing, how are they performing, what's the error rates, what are the most popular APIs, and who is actually my API consumer. And last but not least, thanks to the developer portal in Azure API Management, you have a way to interact with your developer community, so with the developers that really consume your APIs. All right, but what's now in it for the developer? And I'm now talking about the developer at your organization that is developing the backend APIs itself. What's in it for them? Because often API management is considered as something that breaks the flow, let's say, but they don't see the added value always. This is the aim of this session. So first of all, by introducing Azure API Management, it allows you to change your implementation afterwards. And so here currently I have developed a sales API using Swagger and the the OpenAPI specification. I have two operations over there, and I just import them as is in Azure API Management. So we have a get sales apartments and a get sales houses. And we want to expose these two operations as part of a bigger real estate API in Azure API Management. Let's have a look on my Swagger. So this should look familiar to you, a RESTful API where you can do a get and get all the houses that are for sale and all the apartments that are there for sale. So what I've done already in my demo environment, I created a demo API, and I've imported here those two operations as is, and get apartments for sale and get apartments, houses and apartments for sale. If we have a look over here, there's nothing here in this pipeline. So this pipeline is empty, and there's just some XML, but there are no policies in it. So that's because the get apartments for sale, and this one is just a pure pass-through operation within Azure API Management. So here we are actually adding no value yet to the API. So if we go to my Postman, you see that I have here my URL that is pointing to the Azure API Management API, the demo API, and there we do a get sales/apartments. So I invoke this, I'm calling API Management, and API Management is forwarding my call to the backend API, and you see that a random list of, in this case, apartments is returned. We have the same here for the sales houses. Also here, a random list is returned from my backend API, but traffic is flowing through my Azure API Management instance. Because thanks to this, if I later want to change the implementation or the technology of this one, we can do this without impacting, let's say, my API consumers. The next advantage of using Azure API Management is the fact that you can mash up new APIs. So in our demo scenario here, we have another API available for the rental apartments, so apartments that you can rent. But of course, you don't want to say to your API consumers, if you want apartments for sale, you need to go to that API, and the apartments that you can rent, it's another API. No, you want to have a unified experience for them. That's where the API management transformation features come into play. So we will, with the policy, transform the GraphQL API endpoint into a RESTful API operation that is part of the real estate API. So let's have a look on how we can establish this. First, this is here my GraphQL API. Okay. Start from a clean sheet again, and maybe zoom in a little bit. You can do here a query, say get apartments. From every apartment, I want the city, the price, and the description. If I run this, you see that we get, again, a random list of apartments back with the properties that we've asked. I can also include the head balcony to see if the apartments have a balcony. So you see, it's just random data that gets returned, and we see the data.apartments JSON, and there we have the array. All right. So to transform this GraphQL call into a RESTful interface, there we are using Azure API Management. So I go to the rental apartments, open the policy over here, expand it a little bit, then we can see what we've done. So on the request, the request is coming in. The first thing I'm doing is redirecting to another URL, because we don't want to get redirected to the REST API and the sales API. We want to go to the GraphQL API. Our operation is a GET operation, but GraphQL is a POST. So that's why we transform the incoming request into a POST. We make sure that we call the root. We set the content type to application JSON. And here in the body, we explicitly set our GraphQL query in the body. This will make sure that this GET operation will eventually result in this POST operation on our backend API. And on the response, we also want to do something. If you have a look on the response, you see that here by default, there's a data apartments, and then you have the array. But to make it similar to our other API operations, we prefer here to have the array immediately at the root of our response. So that's why here we, in the outbound pipeline, so when the response gets back, we transform the response into a JSON object and select there the data.apartments array. All right, let's have a look on how this works then from a Postman perspective. Actually, from a Postman perspective, I don't see anything. I do here a get on the rental apartment. So for me, it's just OpenAPI specification. And you see everything is working as a charm. And me as a consumer, I am not aware, to be honest, that there's GraphQL running in the backend. So that's very positive. Some cases, Azure API Management can also help you to mock API endpoints. And for example, the front end people, they want to already start building their solution, but your API, your backend logic is not ready enough. You can agree already on the contract and store maybe a JSON file with a static array on Azure Blob Storage, and point API management to that file to make sure that at least they have a static mock available so they can continue developing while you are implementing your complex backend logic. So also here, API management can help. So if I go here to the get rental houses and open up the policy, you will see that here we will point to my blob storage, the mocking container, and there we point to the rental houses.json file. That's an array that I've uploaded, a static array with a response that adheres to the contract. I'm using managed identity to authenticate to this storage account. And for the response, it's just important to set the content type to application JSON over there. Okay, so if we call this operation from within our Postman, you see it's always the same thing, doing a get now on the rental/houses. And you should see that we get a response back. You see, every time I do a call, the response is the same. Why? Because it's a static mock. We don't generate random data in this case. Mocking can be very helpful in the development workflow. End-to-end traceability, very important. Definitely when you start linking multiple APIs together, you want to know what's happening. And if somebody has an issue, he or she calls you, that you at least can see what went on within the system. That's where application insights comes into play. And if you maybe didn't realize yet, but for example, if we go over here, or maybe take this one, in the response of API management, we always get a request ID. And with that request ID, I can go to application insights and find back my traces. So this is here application insights. And if I want to know what happened under the hood with this request, I just copy paste this request ID over here, click on the traces. Here you see all the traces, but the timeline is always more better for the visualization. And then actually here, you see what happened under the hood. So API management did receive this call. It was forwarded to the backend, and this is then forwarded to your real backend API. So you see, this is the RESTful interface. Maybe we can also show the other one here. This is a GraphQL call. So if we also take here request ID and get back to show the search. search also for this one. Yes, and view the timeline. Then you see also here that we have a good detail on what happened. And here you see the nice thing. We did a get on the rental apartments, but this resulted on a post in the GraphQL endpoints because GraphQL expects post. Yeah. So that's really nice to see those things. So end-to-end traceability, very important. Make sure you have every request uniquely identified, and so you can find back your traces in Application Insights or any other tool. Another thing, of course, very important is to harden your security. That's something I've done already on my non-demo API. So what we can do over there, API management has a static IP address, so we can apply IP restriction on our backend APIs. And on the front door side, we can implement Azure AD authentication. So we can enforce that you need to have an Azure AD token and that you need to have the required claims to call this API. So how this is done, let's have a look on the APIs that we have available. I will not go to the demo API, but I will go to my real one. This one is also versioned. If I go here to the policy, increase this one a little bit, expanding like here, then you see that we have a validation of the JOT token. So we make sure that the signature is correct, the audience and the issuer is like we expect. And then we also validate the roles claim. So that's also a very important one. You need to have the right role. So if we go to the Postman, and I call this API, and this one, you see by default I'm unauthorized because I don't have a better token. How can we solve this? We need to, of course, authenticate. I can do this in a technical manner, or I can log into the developer portal where I can explore all my APIs. And the developer portal will allow me to authenticate against my API. So here I'm logged in into the developer portal. It's a little bit customized. We explore the different APIs. For me, the real estate one is most important. I do get operation here, try it out. You see that I was logging in. So here I can see that a better token was added. If we copy paste this, you should see here, zoom in a little bit, that I have the roles claim, which says I have read access on this API. If I now call this API, it should be successful. And indeed, I get a 200 OK back with the responses. That's a very important one. But the conclusion, very important, API management really adds value between your API consumers and your own APIs. Most important, security and monitoring. Those are the key aspects of a good API management solution. For the developer, it allows you to change the implementation of your APIs back afterwards. You can merge multiple APIs into a new one. You can enable mocking, make sure you have end-to-end traceability set up. API management can really work for your end-to-end security. And of course, we all want our APIs to get used by a lot of people. So that's why with the developer portal, you can get broader adoption. So if you're interested in more, all the source codes of the infrastructure and the .NET code and whatever is in GitHub. So scan the QR code. You find a lot of information on my blog about Azure API management. And if you have any questions, don't hesitate to contact me. Thanks for joining this session. Bye.
Thanks so much for that insight, Toon. All right, our next session is OpenAPI, Unleashed Navigating the AI-Driven Future of APIs with Darren Miller.
Welcome to my session, OpenAPI Unleashed, Navigating the AI-Driven Future of APIs. My name is Darren Miller, and I am an API architect working on Microsoft Graph and Copilot extensibility. I also work with the OpenAPI initiative as an editor on the OpenAPI specification. Since around 2021, large language models and GPT-based large language models have become broadly accessible, and the interest in AI has just exploded. But LLMs on their own are severely limited to answering questions from just their training data, which can be years out of date, and it only includes publicly accessible data. The solution to this has been APIs. APIs can enable those LLMs to answer questions that contain both up-to-date information and information that requires authentication and authorization to access. And the most common way that people do this is using a concept called plugins. However, AI orchestrators like ChatGPT and Copilot are still learning how to call APIs. They can do simple ones, but more complicated ones, we're still learning how to do it. And we're still learning how to produce APIs that are easy for these orchestrators to call. And for the next few minutes, I want to share with you what I've learned on this journey in making APIs API ready. LLMs are not called large for no reason. While smaller models are being developed, the best results for general purpose usage still require big models and models that have price tags with many zeros. Incorporating the ability to call APIs into an AI orchestrator that leverages these LLMs is not for the faint of the heart. But tooling like semantic kernel framework and LangChain does get you started, but it's still not exactly a side project. And this is why people have been using plugins to plug into existing AI orchestrators. It has such an appeal because you can simply just use an existing chat experience and then go get questions answered about your own data. But using a plugin, it means those AI orchestrators, they don't already know about your API. They have no knowledge of that API that you created to calculate Bacon's law, or the API that will return the corresponding cat picture for an HP status code. They need to learn how to call your API at runtime. And for that, you're going to need an API description, like OpenAPI. But AI-driven clients bring a whole new set of requirements for your OpenAPI, and it's great that you already have one, but might not be good enough to provide a great experience to these dynamic clients. The AI client needs to understand the semantics of your API call. And like if you have a description that says, get a picture, returns a picture, is kind of as useless to the AI as it is to a human being in reference documentation. And we have to live within the constraints of prompt size and token cost. It costs money to call these large LLMs. And if descriptions in your OpenAPI are going to end up in that prompt, it's going to affect the cost of the call to the LLM. And if you have an API with many operations, it has 50 operations in your OpenAPI description, but you only want the orchestrator to use, say, 3 of those operations, then you're going to need to slice that OpenAPI description into a smaller document. Another interesting topic is API versioning. It's always been a hotly debated topic in APIs, but interestingly, in this dynamic world, breaking changes are really a non-issue because the API orchestrator is going to dynamically discover how to use your API. It doesn't care that that description changed from the last time that it made a request. Now, that's the good news. The bad news is they now need to do more about authentication. We need to do authentication almost semi-automatically. And historically, we haven't been very good at putting authentication and authorization related information into OpenAPI descriptions. Accurately describing those requirements in OpenAPI descriptions is going to be much more important. And last, but definitely not least, we have the issue of trust. The benefit of plugins is that they can provide access to secure data. But when multiple plugins get involved in a conversation, we need to trust that orchestrator not to send our credit card number that we use to book a flight to the plugin that shows us pictures of funny cats who we don't really know how much we can trust that website. So, how do we ensure that the AI orchestrator does the right thing? Well, we give it more information and more precise information. AI orchestrators use the information that they find in API descriptions to provide grounding data for API calls. Without that grounding data, LLMs will hallucinate. It's what they're designed to do. That's why you can give it text prompts and it will create funny images and it will create stories for you based on just a few sentences. We need to tell those LLMs exactly what parameters are needed to make those calls. We need to be able to tell it what methods are supported, what paths are supported, what values are required within those parameters, which one those are computed by the server. With particular parameters, what are the valid range of values of those parameters? If there are dependencies between parameters, how do we know what parameters we're going to send when this other parameter has this particular value? There's no human coding that API call, doing the thing that would be obvious to a human. These are machines and they're effectively dumb. And so our description must be explicit. And that includes being explicit about security schemes and required scopes. But we also must not forget that the LLM needs to connect our natural language question, or the question of the user, to the mechanics of how to make that HTTP call. If we don't provide the right descriptive semantics, the LLM won't find our function, or worse, it will call the wrong one. However, even with the most accurately described APIs, there are scenarios where today's orchestrators are not yet good enough to answer the user's question. If you want your API to be successful today, you may need to provide more scenario-driven APIs. You need to keep it simple for the AI orchestrators. They're not that clever yet. Now, making one call is doable. You ask a single question, you need to make an API call. Chances are the LLM, the orchestrator, is going to be able to do that. It's chaining those calls together by taking the results of one call and passing it to the next that gets a whole lot harder. Now, there's some easy ways to help here. If an API takes a surrogate key, like an integer or a GUID, consider adding a human-friendly alternate key. Discover popular patterns in your API. Where today people are making multiple calls, create a helper function so the AI orchestrator only has one call that it needs to make. And that will also make it easier to describe the semantics of that single call and everything that it achieves. Be careful with the formats that you choose to return from APIs. Things like CSV files. CSV file with a header line that actually describes what the different columns of data are a lot more useful to a machine than a CSV file that's just a bunch of comma delimited values. Protobuf payloads, they may be fast, but it's a lot more work for an AI to understand that content as compared to something like JSON, which is a self-describing format that the AI can understand much more easily. Many API practitioners will tell you that putting verbs in URLs is a poor practice. However, an AI orchestrator is far more likely to figure out how to call your URL that has a cancel in it if it wants to cancel an order, than learning how that it has to do a patch to a status property. Now, I'm not suggesting you add verbs to your URL that are redundant or worse, that contradict the HTTP method. But qualifying exactly what a post method does is often a really good thing. OpenAPI as a description format has become the de facto API, the de facto way that developers are able to communicate to tooling their API capabilities. And it's great for generating reference documentation and client libraries, but there's still plenty of room for improvements, especially when it comes to AI-driven clients. Now, Moonwalk is the code name for our next major release of OpenAPI, and we want it to be able to help you build AI-ready APIs. In order to do that, we need to do a better job of capturing API semantics. And we need to be able to enable authors to be a lot more precise when describing the signature of their API. We're working to apply the notion of separation of concerns to help us manage the complexity of APIs. We're saying that you need to put more information in and be more precise. And we understand how complex API descriptions can become. But doing things like separating the distinction between the instance of an API and the interface that an API provides allowed us to kind of divide and conquer and manage some of the complexity. And this is going to be especially important in this new era of AI as a client. Now, OpenAPI is an open project effort. Anyone can join and contribute. There's no membership fee to participate in our technical work. You just have to show up and be willing to work. And we're looking to deliver Moonwalk in late 2024. Thank you for taking this time with me. I hope you found that useful.
Welcome back. And if you're just joining, we have an action-packed day of APIs in action. Now, of course, if you're brand new here to the Azure Developers YouTube channel, make sure you subscribe so you stay up to date every single time we put out a new video. Next up is an awesome session coming from Joel on API Design First with SwaggerHub and Azure API Management. Take it away, Joel.
Good day, everyone. My name is Joël Hébert. Today, we'll be talking about API Design First with SwaggerHub and Azure API Management. Let me ask you a question before we begin. Are you looking to move to an API first design? Are you utilizing code first today and looking to have that paradigm shift? Look no further with Azure API Management and a complementary service in SwaggerHub. What we're looking to do here is introduce the first steps, combine both, and see how they are complementary when utilized together. Azure API Management SwaggerHub enables you to have better collaboration by doing API first design and enabling it into Azure API Management. We can have some certain benefits by doing so, like evaluating the design contract beforehand and looking at security flaws earlier in the SDLC. Let's take a look at the different methodologies and how we can enhance the way that you can do API first design with Azure API Management. So first and foremost, let's talk about code first and design first. Two different paradigms. I like to call this the battle of priorities. So on one side, you have speed, one side, you have quality. What we want to do here is discuss the different personas at hand. API product owner, product manager, could be a project manager, and the developer. Let's take a look at some of the battles of priorities here. So developers are eager to code, and API product owners who are insisting on clear API contracts. A second notion, developers argue that time spent on design delays actual implementation. Product managers worry that hasty development leads to technical debt and maintenance nightmares. By evaluating these sort of battles of priorities here from these two different personas, you can kind of get the pros and cons from code first, where I want to go ahead and code, get my ticket done, move along, let's get this to production, versus the scenario where you are API product owner and time to first call is important, but you want to have that redundancy and other things implemented, and definitely add those to your product. Let's go ahead and take a look at a demo where we will see firsthand the interaction between SwaggerHub and Azure API Management. So what we will do here is delve into the actual demo. So let's start our journey in SwaggerHub, where we have an API named the Simple API First Example. Here we are working with some JSON and an open API spec where we would like to collaborate and utilize API first design. On the left-hand side, we have the code editor. On the right-hand side, we have the UI view. Both affect each other. On the left-hand side, a change will come in effect, the view that we see here. on the right-hand side where we can try the API, we may peruse it, and definitely we can send it to mock endpoints. But our goal is to send this API spec here to Azure API Management to enable API first design. So let's take a look at the integration. So I have two integrations at present. So I have Opulent ASP, which is Azure DevOps, and APIM Demo API First. And that is the integration to API Management. So let's go ahead and add one. So I pick API Management. And I've already done this previously, so I won't need to redo it. But for you, a simple login and some role-based access control, and you're on your way. So let's take a look at this in action. So I'm going to execute the rendition, and let's see what occurs. So we get a sort of a pop-up here telling us that the integration was executed, and fantastic. This is going to go and virtualize the code here and insert it into Azure API Management, and we're on our way. Shifting gears, now we're in Azure API Management. Fantastic. We can now take a look at what the effects are of that virtualization, where the API is now ingested and virtualized into our appliance. Excellent. So now what we've seen, let's do a small recap. In SwaggerHub, we actually took the code and the design that we're working on, and we're able to transport it into API Management. So as if I were to put my hat on now as the product owner, I can now go into the portal and start perusing the API that I want to showcase to my consumers, those that are intended to utilize the API for that developer experience. And I would like to work on having a great experience on that first call from those practitioners. The practitioners also utilize the try it feature here and peruse at will. The next element of concern here is the actual flow. So now that the My Inventory API is inserted, I'd like to alter the flow from SwaggerHub to not go to a mock or another appliance, but have it flow directly to the My Inventory API in the secure flow where I've deployed my API management. So this will lead to fewer bugs later on, and especially those related to security. When we have a whole bunch of security appliances added along that path. Let's talk about design a little bit here. What is the experience that you have when you are doing API design first in API management? Little known fact, if we go to the front end artifact here, there is a JSON viewer. And in that JSON viewer, it does allow me to do things that are similar to SwaggerHub, where I can add operations, definitions, and tag objects. But how do I collaborate in this element? How can I say that at number 12, I would like to change the name of this operation, I need to put this as a post, and I would like to collaborate. Well, here comes Azure SwaggerHub, and it's construct for collaboration. So do note here that it does have the possibility to augment and share and collaborate with other practitioners, whether they are the team, those that are intended to consume it, internal, external. What we want to do here is actually look at the resolve comments and the open comments that we've worked in unison with the practitioners. So once again, let's take a look at a real live example here. So at a certain line, someone said that a 200 OK was not good practice and we could change it for a 201. This was remediated in the code. You can definitely go here and interact with the integration team, citizen developers. Everyone feels like they have been added to the conversation, and it creates great synergies amongst team. This was a great team building artifact for myself. Shifting gears to this server view here, you'll notice that there are more than one. So I have 4 different server views here that I can utilize. The top one being SwaggerHub, which is the mock engine. What we want to do here is illustrate that we can take the rendition that we have here and fire it to different elements. We don't always want to go to the mock. We at times want to go through all of the security appliances and the secure flow through our API manager to detect security issues very early in the process. This said, let's talk about these security issues. Let's talk about shift left considerations. Now, this is a term that we normally see in the security landscape, right? Shift left security. What this entails is usually before writing any line of code, all of the security appliances are created and they are scanning automatically. before deploying to anything, even on my local machine. When we think of this in the API design first landscape, we think of it in this manner. We want to move the API design, which I just showcased earlier in the process, and the flows of our APIs through the security appliances in our secure flow has to be done immediately, even when we are starting off and just mocking. Here I have a list of different servers. You'll notice that the bottom one there, we have a firewall app gateway. So that could be going to an IDS, IPS element. We could be firing directly to the API manager portal. These usually have appliances in front of them, and we definitely want to utilize them. What does a natural flow look like? Well, here, Azure Application Gateway enabled with a web app firewall, Azure API Management, and then the mocking that we do in its backend to pretend that there is an API there. By doing this, we will see that there are two different scenarios that usually arise. Scenario one, the developer is utilizing code first. With this code first, he has not deployed the secured flow where the API is intended to reside. Post-production of the release, the WAF is blamed for bad API design, where a string is defined as such. So we have a string here instead of a JSON array. It goes Canada, pipe, USA, pipe, Mexico. What occurs here is on the 13th rendition, this is going to trigger a signature in the WAF, and it's going to cause a 403 forbidden. Now let's take a look at what can occur here if we actually use scenario number 2. We're going with design first. We're in SwaggerHub. We're designing. We're testing early the different mocks that we have in that secured flow that I discussed, right? Not necessarily mocking, but we're going through the secured flow. The WAF is monitored, the poor array string design is caught, and the fix is issued. So here we have a natural JSON array, something quite simplistic. This would have been caught at design time. Why is there a funny string with a whole bunch of pipe delimiters? Would have been fixed at design time. If it would have been missed, it would have went through the WAF and got caught when somebody would have selected quite a few different countries, and we would have done our shift left due diligence, both in design and security. Moving along. So now you've got a design you're working on, you virtualize it, it goes to the API management appliance, you're doing mocks, everything is grand. It's now time to scaffold or code gen for you to get some code. Do take a look here. We have an Azure API Management extension for Visual Studio Code where you can effectively scaffold if need be. What occurs here is you'll go ahead and select the API, and then you can scaffold an Azure function, effectively creating an Azure function for you to work with. What does this look like in SwaggerHub? Well, SwaggerHub offers quite a few other different options. It offers the client SDK or a server hub or the documentation pane or simply downloading the JSON of an API. Let's take a sample here of a real world scenario where I'm going to select the server stub and I want to generate the code for an ASP.NET Core hosted element. But before doing so, remember when I selected my two integration points? I had one for DevOps and one for API management. I showcased the API management one. Well, now let's just take a look at what occurs if I were to integrate Azure DevOps services in this flow. Well, there are two ways of working. The middle icons there, you can actually download this element, work off your workstation. But if you use the integration, it will go and push the code into your DevOps rendition. And you can also implement versioning and branching if need be. Do note that this is also available in GitHub as well. I'd like to take 2 minutes to talk to you about a real world scenario to give you some value. Here we have Azure API Management fronting Azure Service Bus for externally facing clients. I have an Azure API Management in the middle. What it's doing is effectively fronting a queue for me. Why would I want that? When I have to share constructs from a queue, I have to share credentials. I have to share a schema. I have to share the address of the service bus. But what if I pretended that all of this was fronted by API Management and it was all an API? Well, let's look at how we can do this. By going to SwaggerHub and doing the API first design, I designed a contract, send it over to Azure API Management, where I'm now mocking, utilizing design first and the Open API spec. And now I can start firing requests and seeing how that API Management appliance reacts. The second step would be to apply APIM request validation. When somebody puts something on a queue and it's erroneous, we end up with a poison message. That can be problematic because it's already ingested in your backend. But here we're going to utilize APIM request validation, send it back to the client, please remediate, send it back. If it's good, we're going to do a service bus call by using a REST construct to the service bus, and away you go. The flow is now done. The main advantage here is my client at step number 3, who is sending in those requests, can peruse my portal, can onboard in the same natural way, which it has already done in my API program. And lastly, if you look at the red element there, no functions to do data transports. I don't need to have 15 of these in my program to simply take something from APM and transport it over to a service bus. So what did we see in today's session? Let's take a look at the benefits recap. So first and foremost, and at the forefront, is collaboration. So when I think of Azure API Management and its synergy with SwaggerHub, I think of a service that is complementary, and that the SwaggerHub is there to enable you to do collaboration. So utilize the collaboration and sharing features, which they differ based on if you have the free tier or the more advanced tiers, but do take a look. Absolutely fantastic. And one of the first tools to get going if you want to do API first design with API management. The second element is this whole notion of shift left, not only for security. Designing can be done in early stages, and it does enable you to do a few different things. By virtualizing very early, your API product owner can now go to your API portal and do some oversight and testing and project himself as the consumer that's intended to utilize the portal. So gets the eyes on the prize nice and early. As the practitioner and your security team, we are firing executions to the security appliances early in the life cycle. So I showed you the 2 different scenarios. We can catch things really early, even during API design. If there is malicious or erroneous design, we will catch it early in the life cycle. The earlier, the better. Last and not least, if you want to use some of the more premium offerings in SwaggerHub, validations and contract testing is available and should be part of your program. Do peruse and augment. Lastly, this is what I call choose your own adventure and scaffolding. So scaffolding is the art of code generation. We took a little bit of a look at what was inside of SwaggerHub and what was available to Azure Functions. But in the end, familiarity is productivity. The only thing that I suggest is that you standardize on something, not to have the spaghetti code of many years ago. Select something, put it into your life cycle, and away you go. This said, I'd like to propose this call of action for you, and we will be sharing these links. Start off with the integration into APIM. Give it a test. The Swagger free rendition and API Management Dev allow you to do so. Take a look at the code generation features and discover for yourself how API Management and SwaggerHub are complementary to each other. And on that, I'd like to thank you for your time today.
All right, welcome back. If you're just joining us, make sure that you get your questions into the chat because we have experts in there answering all of your questions. So we want to make sure that we get as much of your questions answered as possible. But for our next session, we have upcoming API developer experience with Josh. Go ahead, Josh.
Hi, and welcome. Today, my session is going to be about the API developer experience using Azure technology and the Microsoft stack. I'm Josh Garverick. I am a cloud solution architect. I work currently at Zebia in the Microsoft Services division. I've been in software for almost 2 decades. I've played in the DevOps space, in the cloud architecture space, and all points in between. So really excited to go through some of these items with you and go through a couple demos. So let's begin. We're going to be covering a couple of different topics. One is going to be the general API development experience in the Microsoft Azure ecosystem. And I also want to talk through the API development experience from the perspective of the easy path and the hard path. Now, in a lot of cases, a lot of demos that may be out there you see will be a lot of clicking around the Azure portal. And I do want to go through that a little bit, but I do want to also stipulate for folks who perhaps have more stringent guidelines on what they're allowed to access, that there are ways that you can still perform a lot of these activities without having to go to the portal and without having to have write access on a lot of these individual resources in Azure. We're going to round this out by talking about API documentation and discovery. And we're going to touch on a couple of nice preview features that are out there that will actually help speed up your ability to find and use APIs in your organization. The short story is that the API developer experience can feel a little disjointed. There are a lot of disparate tools that are out there that you can put together. Like I said, you can also use the portal to go through and do things, but again, you'll be jumping between different blades, different resource types to be able to make that happen. It doesn't have to be that way, though. You can actually do everything from one interface, and we'll talk about that in a little bit through the use of code spaces. Before we get to that, though, I do want to just kind of reframe the gravity of what we're talking about. Go a little bit further into detail. You can build a seamless and consistent developer experience using a few different things: Visual Studio Code, code spaces, Azure API Management, and there are other Azure services that you can also integrate to give yourself a nice rounded experience. Nice caveat with code spaces is that you can also use it as a dev container running, on your network or on your personal machine, and still get the same benefits of being able to use all the goodness that comes with code spaces. There are a couple of extensions for VS Code that are really handy. We're going to be talking about those as well. One of them is the suite of Azure extensions, as well as a couple around API inspection, authoring, and testing through the OpenAPI extension, as well as the Postman extension. And just as a reminder, I know I mentioned this a couple minutes ago, for those who have really strict role-based access control or RBAC governance, where they're not allowed to access the portal or access specific resources, this gives you some options. Okay, so you shouldn't feel like you're boxed in because of security requirements or other constraints. There are still ways to work through these things. Another point to keep in mind is that a little upfront maintenance, cataloging, care and feeding goes a long way towards making sure that your APIs are visible to others, and if others are reciprocating, you can find out information about those APIs as well. It's really key to have great documentation and have a vehicle that will allow you to discover these APIs in a very clean, consistent, and fast manner. Something to keep in mind when we're talking about API development is that it is a very large portion of our industry. And I know that we've all been likely developing APIs for some time. Personally, the first API I worked on was the SOAP API about 15 years ago. And of course, we've come a long way since then. But around 90% of developers are using APIs in some fashion, which is a very large amount of the development community. 84% of businesses are also using APIs. Now that is inclusive of internal consumers as well as external consumers. So for folks who expose APIs outward to allow partner integrations or anything like that, those are all included in that figure. By 2025, they're looking at projecting an economy around the use, development, and maintenance of APIs around $267 billion. Billion with a B, that's a lot of money. Further to that, once you start to look at more of the business justification side of things, companies that use APIs have a 24% greater chance of being more profitable because of that inclusion in their catalog. There's a 20% improvement roughly in customer satisfaction when folks are implementing APIs versus when they're not. And it can also help up to 15% with reduction of cost by streamlining operations and making things easier and more self-service. So we're going to talk now about a couple of different aspects. Like we mentioned earlier in the table of contents, we're going to be looking at the overall experience as well as some low bar of entry and high bar of entry. So some things that take a little bit of work, but hopefully through the course of these demos, we'll actually be able to look at that, and it won't be as daunting for you, because there'll be some sample code and some pointers on how to best use the tools that are out there. So we're going to jump into our first demo now, and we're going to talk about code spaces. We're going to talk about the API management object in the Azure portal. So we can cut over, and you can see here we've got standard code spaces set up. Well, maybe not completely standard. You can notice there's a little bit of formatting going on here with the prompt, and that's because I happen to like OMyZ shell and Powerline and a few other things. So these are all included in the configuration script in the container config file. So rest assured, if this is something that you're interested in, along with the other things around extensions and everything else, you'll be able to get your hands on these. Now, we're going to take a look at a couple of different things. First of all, what I'd like to do is go into the Azure extension. Specifically, there's an API management extension that gives you a couple of things. One, it allows you to browse through here and see the different major components of your APIM instance. It also allows you, if you have permissions, to go in and edit these as well. I'm going to steer away from that a little bit, mainly because I tend to like going infrastructure as code and writing that from the ground up, so that way it's repeatable, reliable, and doesn't have as much of a manual intervention to it. But be that as it may, you can, in some cases, actually get access to the Azure portal, and you can go into what you will see here, which is the APIs pane, and you can define a new API. You can create it from a definition or a spec file. You can also, like I mentioned, use infrastructure as code to be able to provision an API in here, uploading the documentation and all that good stuff. These things are pretty simple, pretty straightforward. Really, when you go to click on one of these, you enter in what you want it to be called. You enter in the name of it. It'll generate a URL for you. And then if you just want to put a URL suffix in here, that'll be your endpoint that you're going to call. Okay. If we look at actually filling out the definitions, you can add operations here. These are some that are pre-created based on an example that I have. And when you click on these, you'll see some of these values change. And that's because there are return codes and policies and things that are in there. One of the things to keep in mind with API management is that there are generally policies that will help you secure, redirect, or even return mock responses, among many other things. And being able to have the granularity to go down to the operation level or to come back up to the API level and actually, make sure that these are in place. It's very handy. Now, quickly, we'll go through this. This is an example of a policy that's at the API level for the Echo API. And this gives you the ability to filter based on the method that's coming across. So in this case, there's one for if someone hits this endpoint with a patch method. There's another one down here if it just hits it with a regular get. And it will formulate a mock response in either instance and put that back to the user. Now, how would you do that over here? Well, I'm glad you asked. In order to go through and update policies, you can actually click on them here in VS Code, and it will pull up a copy of what we were just looking at. Might take a moment for it to format, but you'll notice that all of the same information is here. We can still go through and add, edit, update, whatever we like. An additional thing that comes with the API management extension is policy snippets. So you're actually able to go in here and enter in an additional block, and it will help you fill that stuff out. Now, you'll see some of the auto completion come up as well. That's due to me having Copilot installed. So Copilot will give you that kind of automatic code completion based on obviously the wealth of information that is out there on GitHub. So you'll also notice here that it's consistently nagging me to upload my changes. I'm going to ignore that because we don't need to do that right at the moment. But this gives you a quick way to at least be able to go in and do things with policy. You can also import from OpenAPI, either a file on your file system or through a link. You can import these from specific cloud services. So if you have an API that's running in an Azure App Service, in an Azure function, and it's exposing that endpoint as well as the specification for it, you can import them right here, and it will bring those into your API management instance, which is definitely helpful, but it does require you to have the ability to access those services. If you can't access them either through the endpoint or through the portal, these probably won't do you too much good, but they do exist, so they are out there. Like I mentioned, one of the things that I like to do, let's get some of these collapsed here, is I like to start fresh, ground up infrastructure as code. So in here, you can see I've got a couple of different folders. I've got one for infrastructure. I've got one for the source code for this Echo API. There's a templates folder in here as well. That's something that gets put in there when you import an API from APIM that happens to be out there into your local environment. It'll actually generate for you the spec file and any of the other templates that you're going to need. So in here, you can see I've got plain vanilla Terraform, and this is going to go through and actually create an API management API object. So this will allow us to create an API within the APIM instance that will hold the information for this Echo API. Now you can also see here that I'm importing the specification from a file, and that is coming from this file right here. A very plain JSON representation of an OpenAPI 3.0 spec. I mentioned earlier that there's a OpenAPI or an OpenAPI extension. And if you have one of these open, it will give you the ability to go through and decompose this at a bunch of different levels. So you can go through and look at it from the paths perspective, and it's going to break this stuff down for you relatively easily. Now you can go through these and look as well, but this does help you with being able to see things in more of an outline format as opposed to just plain old JSON. Having access to that, you can also use Postman to connect to your personal account or your company's account, pull in and use Postman collections to do everything from testing to creating mock servers to creating mock responses, mostly things that you can do with the Postman desktop application or on the web. You can also do with VS Code and the Postman extension, which is really a nice change. So that way you're not context switching, you're not window hopping. Everything that you need to do is right here, right in front of you. So that is the end of our first demo. We can hop back to our slideshow. One of the things that I like to go through as well is to talk about additional use cases for GitHub Copilot. And in the event that you're doing something that is brownfield or, existing code, legacy code, any of that stuff, GitHub Copilot gives you the ability to be able to do things like extract open API specs. It allows you to convert policies and scripts from another API management product to Azure APIM. Specifically, an example of that, I've done that for converting Apigee APIs to Azure APIM. And it works fairly well as far as being able to translate between the two types of policy files and incorporate the scripts where you need to. It also helps you with explaining, documenting, and refactoring of API code, which is, as we all know, one of the things that we probably like to do the least is documentation. So having a hand in that is definitely helpful. Now, finding APIs. We've talked through some examples of how you can edit different things in APIM, what the ecosystem looks like. How do you actually find information? Fortunately, we have a couple of different options. One is the developer portal. So if you're not familiar, Azure APIM has a developer portal that you can enable that will give access to folks both internally as well as externally, if you choose, to be able to look up information about APIs that are being published through APIM, as well as to test them out in some cases. There's a mechanism in APIM that allows you to create what are known as subscriptions to specific APIs or to API product lines. A lot of stuff that is beyond the scope of what we're going through today, but definitely a good thing to go check out. Azure API Center is a newer Azure service that's currently in preview that allows you to kind of gather not only API information, but metadata about APIs, which is something that APIM doesn't necessarily do in a straightforward manner, which is why API Center might be a good idea if you want to categorize things by like line of business or by functionality, by environment, if you're doing things like design versus development versus production, that type of thing. It can also help you track APIs that you retire. So you can still keep those definitions around, but you can mark it as not being currently active. So at least folks have context as to what you're looking at there. Now, APIC, API Center, and GitHub Copilot have an interesting integration as well, which allows for you to query the API Center directly. All you need is read access. And it will actually pull up either a list of APIs that are currently being shown to you through API Center, or you can query it for specific types of APIs. For example, you could go in and ask it for all gRPC APIs. If you need a specific REST API for accounting functions, you can use Copilot to actually query against that information and get you what you need. And then obviously at kind of the lowest level, you've got OpenAPI and Swagger to help you with that documentation and making sure that it's available to folks so that it can be discovered easily. Now we're going to jump into our second demo. First, we'd like to take a look at the integrations between Azure API Center and GitHub Copilot. Now, in order for us to effectively be able to look at this integration, you do need to have Visual Studio Code Insiders installed. That's really important. You'll also want to make sure that you have the API Center extension as well as the GitHub Copilot chat extension installed. First, let's take a look at what you can see when you go into the API Center extension itself. So you'll notice here, there are a couple of different pieces of information, some auto-generated numbers for the APIs. That's because I used a script to import those. It'll go through and it'll give you some information on deployments, as well as any versions that are being cataloged currently. You also get some information about the environment in which those APIs are related to. Now, to get some additional information, what you'll also want to be able to do is take a look at GitHub Copilot. Now, the API Center integration with GitHub Copilot is really interesting and it's really easy to use. So for example, all you have to do is type @API Center, and it's going to prompt you for one of two commands, either /list or /search or find. So if I wanted a whole list of all of the APIs that are currently available to me, I would simply enter list and retrieve that. Now, if I want to find one specifically with some metadata around any APIs that are currently being used by accounting, assuming that a line of business tag has been added, once you press enter, it's going to search through the metadata available to you. And then if anything matches, it will be able to give that back to you. If not, you'll get a response basically saying this won't be something that's available to you. Now, in order to get the full list, we can just do list. And what should happen here is it should pull back a full list of the things that are being captured in API Center right now, relevant to your specific environment. And as you can see, there are a couple that have come back that are specifically installed in API Management and also updated in Azure API Center, all through the use of the GitHub Copilot integration. Now, secondly, we also have the ability to go into the API Center and use what's known as the APIC portal. This is newer functionality. It allows you to wire up an authentication mechanism to go through and ensure that only folks who are supposed to have access to this have access to this. This is what API Center portal looks like. And you can see here that it's basically prompting me to sign in because otherwise I can't see what's going on. So I'm going to sign in, give this a moment to load, and you'll see it comes up with a nice panel view of the different APIs that I have access to. I can filter them by type. I can filter them by lifecycle over here as well. And then if I were to just go into one of these quickly, it's going to give me the ability to swap between versions if there's multiple versions, if the definition format is a default version, or if there's something else that I can pull. It also mentions where it's deployed as well. So you could have multiple deployments that this API is living in, not just Azure API Management. You can download the definition and it will give you more information if it's filled out. So again, it's only as good as what you put into it. But there's definitely some great information here, and the integration with Visual Studio Code itself is bar none the coolest thing, because that greatly simplifies where you have to go to get information about your APIs and how best to use them. All that information gets returned back to you, again, based on what you put into API Center. So that concludes our second demo. And I'd like to say thank you for taking the time to listen to this talk today. And feel free to reach out to me on the socials. My handle is @jgarverick. Happy to answer questions, and hopefully folks can find some usage out of the code samples and everything that will be accompanying this. Thanks.
Welcome back, everyone, to APIs in Action. If you're brand new here, make sure you ask those questions in the chat and jam on the subscribe button as well. We have a great day. We're only halfway through our awesome sessions on APIs in Action. Next up is Massimo talking about better API governance with Azure API Center. Take it away, Massimo.
Welcome everyone, I'm Massimo Crippa, and in the session today we will talk about API governance with Azure API Center. So building an API program is something that is pretty complex, right? So it's like, let's say, building a digital product. It all starts from the idea conception to the implementation and beyond. It's about put yourself in the customer's shoes, think at APIs as a product. It requires also to have a focus on delivering an excellent user experience, put in place the right governance, and so on. So in this context, there are different roles, so business roles, technical roles, and as you can see here, this is an example. Product owner is necessary to be involved, business analyst, and on the other hand, API architect, so also the developers from API's point of view, but also from app, the one that is dedicated to BFF, the other one that are more on backend and so on. So a lot of roles might be necessary to be successful in an API program. And different role, of course, that comes with different objectives. Here there are some objectives grouped and some examples, but there are way more. And most of the time, those technical and business groups of people, they come together and create virtual teams to collaborate. So to collaborate on the governance, to collaborate on the versioning and life cycle, so to manage deprecation, to understand which version have to be phased out and which version has to be promoted, to which environment. What about developer experience? How about to promote the adoption of your API and so on? So again, different roles, different objectives. But then, as I was saying, they have to come together. They need to come together with procedures, but also with tools. A tool that, for example, an API catalog is something that it's really necessary to be successful in your API program. And it's something that is necessary to discover the APIs. It's something that is necessary to keep an eye on the governance. It's something that it's very important to foster the reuse. And in this context, Azure came up recently with an offer called Azure API Center that can be your Azure, that works as act as an API catalog. It helps you to create an inventory of your APIs, no matter where are located. So if there are in a cloud, in a Microsoft cloud, in another cloud, if it's on premises, and also no matter which technology are you using for hosting, can be function, can be Kubernetes, can be API management, Kong, etc. It helps you to track the information about the APIs, so and manage the governance model. So wherever your APIs are in your flow to the production, it gives you a view on where they are, which kind of deployments has been triggered, and to which environment. And at the end of the day, as I was saying, it maximizes the developer productivity and facilitates their use. Now, in this session, I want to dive a little bit into the API Center, and we will do by focusing on two personas. Of course, there are a lot of personas. We cannot look all of them. The API catalog is bringing, or will bring, hopefully, an answer to a lot of those personas. But today we look API Center and API developer. API product manager and API developer. From a product manager point of view, the product manager wants to understand and having an idea of all the moving parts, how they come together at the end of the day. And on the other hand, we have the developers that wants to make sure that he can find an API and fetch the OpenAPI specification, for example, and make sure he can or she can easily do the first call, the first successful call. Here in this in a workflow, there are, for example, two types of developers. The one that produce, the one that develop the APIs, and the one that consumes the API. In this case, our developer that we are looking in this example is the one that consumes the API. Now, said that, I love API design first workflow. So I took this example where in order to build our API and then roll it out all the way to production, we start first with the OpenAPI as a source of truth. So we design it, and then we just, as a second step, we mock it in API management, for example, so we can then get a feedback on the usage, get the feedback on how this has been designed, get the feedback from a user point of view. So we close as soon as possible the feedback loop, and then we can move on to build it up, to deploy, and then to measure and get that feedback from the real usage. So with this workflow in mind, let's move fast a little bit. So I want to show here what is the role of API Center. So someone produced the API design, and then my CI/CD, when it takes this design, it validates the design, and then promote this API into the API Center. So a Rocket API exists and has been validated and is in a lifecycle stage design. So then someone else can go discover these APIs, assess the compliance, assess, for example, the security, assess if it follows the best practice and the company standards, and then, okay, give the feedback, we are good to go. So our developers, they can start developing the API and then eventually go to development, and at the end of the day or at the week or the month, move on to the next stage till the production. This can be done for one API, but also for multiple versions of the API. So in this story, we have at the bottom right our API PM that can follow up, thanks to the API Center, all of these steps that our Rocket API goes through. The second persona is our developers. You want to go and fetch the data that are available in our API Center. There is a lovely Visual Studio Code extension that allows us to quickly connect and navigate the API Center. The developer can discover the API version 2, and then can fetch the OpenAPI specification, generate, for example, the HTTP test file, and then if he or she wants, create an SDK by leveraging the Kyoto open source tool. So that's how he can or she can discover what's been published. Now it's time to see API Center in action. So I will switch to first this Azure DevOps. So where I do have 3 APIs, let's first see this Rocket API. Here we have our release pipeline. Let's see what happened. I have a static validation in this case, so I can check it in my OpenAPI specification. I use Spectral to validate that everything is compliant, the company rules. When it's fine, I have a publishing. So I can publish in OpenAPI Center. Let's see this. So I then create the API in the API Center. I create a version, so which version of my APIs I'm publishing, and then I can import the OpenAPI specification. All of these steps are done by using the Azure CLI, so as AZ, APIC. In this case, is definition create. I pass the APIs, the resource group. I pass the name of my catalog and all the other details that are needed. So I first create a definition, and then here I can specify the OpenAPI specification that I read from my repository. So with this, so I will be able to say, okay, to state to my company, to the audience of the API Center, okay, there is something that is in design phase. Then I can, as I was saying, publish to API management to mock it, and then when you are ready, for example, push it to the API Center, so deploy to first to an environment, and then state into API Center, okay, a deployment happened. So I can register a deployment still using the AZ API deployment create, and then I can, as a last step, update the lifecycle from design to development. Okay, now let's move on. So this is you can see this version went all the way to production, and other APIs like Sales API, they stop at design because the design was not fine, was not okay, and then the password API, for example, is has been blocked here to the validation, and in this case it went all the way to testing and is waiting to go to staging. Now, with this in mind, let's see what happened, for example, for the Rocket API with this scenario in the API center. So we go to our API center. Here we do have our APIs, and here we have the Rocket APIs and the password APIs. As you can see, Rocket API is in production and one password is in testing. So here we go to Rocket API, we can just have all the details of our APIs. We can add some custom data using the metadata part. So we will not see in this session how we can customize this, but you can add field, you can add simple field and also complex object, and manage the how to say the structure. Then we do have the versions, the version that has been published. You can see that there are the version 04 that is stop at design, 05 stop at development, has happened here. So we went all the way to development, but then it's been cancelled. The version 01, it went all to production. So if we go to our deployments, we'll be able to see that the version 01 here, it went first to this kind of environment, the test, acceptance, etc., etc. So I can then click on my link and go back and see the pipeline that released the specific environment. So this is for the Rocket API. So version, deployments, I can follow up in which stage this API is. If I see, for example, the Rocket APIs over there, oh, sorry, I wanted to say the one password APIs. Over there, we will see that there is two versions, but the deployments will be only for the testing, because the one password here never hit a deployment, so they stop to the mocking. So if I go on deployments, I only have the deployments of the version S24. This is basically what you can discover, and you can how you can use the Azure API Center to discover what you have, your APIs, what has been published. There is also a nice portal where you can go, and I'm not authorized because probably I just recently, or I have to sign in, where you can find the same kind of information in a nice user interface. As the last things, I want to look at the developer experience. So from the developer experience, we go to Visual Studio Code. As I was saying, we have here an extension where you can go and fetch all the APIs. In this case, I have my one password APIs. I can double check the deployments, which versions has been deployed. In this case, I take the 24 that it's present in testing. I can find my definition, my OpenAPI definition. This is a standard company standard of a customer. I can go and check the documentation, and then the Swagger style it come up. I can go and see, and for example, and test this API. Okay, here I don't know if I count properly, but I need 26 or so to make it run. But okay, it doesn't matter. So here there is a regex that is kicking in. So let's move on. Okay, I can also generate an HTTP file and test the API this way, or if I want, I can, as a final step, generate a client by using, for example, as I was saying, Kyoto. So here I want to say I don't need this activity and this health. I also don't need heartbeat and metrics. Let's say I want to create a client for my volts, in this case only get. So then I can press on play. It will ask me like very quick, let's do API client, let's do API SDK, and let's call it in SD. Let's create in SDK as then API center rocks. I choose C#, and then I can see here that all of these classes being created. If I go back to my code under SDK, that's the result, and I can create and I can call then my API if I want using this SDK. Okay, that's it. That's what I created for you today, and it's all for you. Thank you for attending this session. I hope you like it. Have a nice day. Bye.
If you're just joining us, welcome to Azure APIs in Action. We're so excited to have you here with this jam-packed schedule of all things API. That last session was amazing. Let's go ahead and get on to this next one. Leverage Postman to collaboratively test your APIs from design to deployment and beyond with Sandeep and Garrett. Take it away.
Welcome to today's session on leveraging Postman to test your APIs collaboratively from deployment, all the way from design to deployment. So I'm Sandeep Mursapalli, and with me we have Garrett London. We're both part of the solution architecture team within Postman. So for today, we have a quick agenda for you, right? So we will do a bit of platform overview. We'll start with the Postman platform overview, and then we'll get into how Postman is relevant for the APIs that you're deploying on Azure, or the APIs that you already have on Azure API Management. And then we'll touch upon a couple of demos. We'll show you a demo of how you can use Postman in the API lifecycle in the design phase while you're prototyping the APIs, getting your design right. But also we'll show the second demo, which will talk about how you can use Postman to test your APIs across your API lifecycle. So that let's get in. Almost all developers actually do know Postman, but if you haven't heard about Postman before, over the last decade, Postman has become this platform of choice for developers who are using APIs, who are testing APIs, who are trying to integrate APIs into their applications. Right, so today we do have around 28 million plus developers who are using Postman to improve their API experience. But because Postman is such a popular tool, sometimes what we see is a developer's understanding or user's experience of Postman is sometimes a bit dated. For example, if you have been using Postman 5 years ago, maybe your understanding of Postman is a REST client, or you may be using Postman as a testing tool. But sometimes that understanding kind of remains there, right? But really speaking, in the last 2-3 years, we have developed Postman into a purpose-built platform to improve the API experiences, whether you're creating APIs or whether you're consuming APIs. And that is what we wanted to show today in like the slides as well as the demos that we'll touch upon. Right, so a big part of the use cases, the secret sauce of Postman really is the collections. And these collections are something that you may already be used to today. Technically speaking, collections are a group of executable API descriptions. They are interactive documentation. But practically, in terms of how we see developers using it, we see collections addressing a lot of use cases, like including whether you're demoing your API, you will create a collection for that. You're creating a recipe or a blueprint of how 3 or 4 of your APIs will come together, maybe along with some third-party SaaS APIs. You will create those recipes and tutorials in Postman as a collection and share that with other people. One of the interesting use cases we're seeing is around debugging, especially if your API is being used by third parties. a good way to debug is for you to kind of share the collection, send it across, save examples and things like that. And today, from a lifecycle standpoint, we'll touch upon some of the use cases on how you will use the collections in more detail as well. Like some of the examples we'll touch upon are mocking and API lifecycle. So in terms of, like bringing it together from bringing Postman into the Azure context or Azure ecosystem context, really, this is the life cycle that we kind of see a lot of APIs go through, right? So if you're a producer, you start with defining your API. You think about what your API is trying to solve, and that definition of an API then it goes into design. Eventually, there'll be an engineering team that will go about building or developing this API. Eventually, that API will go into Azure API management from a deployment standpoint. But before that, you may be using serverless, you may be using Azure VMs in order to create and deploy these APIs in the runtime as such, as a microservice. So once the API is out there, from a consumer standpoint, you would find the API through a developer portal, or sometimes you find the API through a collection shared by the API producers or other team members. From there, you will go about integrating that API into your application, and that is the lifecycle of a consumer if you are using that API from a consumption standpoint. So the essence is the API lifecycle is not just one single lifecycle. There's a producer lifecycle and a consumer lifecycle, and Postman has a role to play along with other stack that you have in your API tooling, your API gateways, your serverless deployments, all of that. Right. So hopefully today we'll touch upon some of them in more detail in the demo, but this architecture diagram, I do understand that this image may not be readable. We'll give you a link to this image and maybe the slides as well. Towards the end of the session, we have a QR code that points you to a workspace. There will probably give you the link to this diagram in more detail. But at a very high level, the idea is if you apply those two life cycles, the producer life cycle and consumer life cycle, to a workflow, you start somewhere, right? You start with either a code that gives you the spec, or you start with manually editing the specification if you're design first. In addition to those two, one thing that we're going to demo today is how you can use Postman to prototype your API and use that collection as the basis for how you generate this API specification that may eventually become an open API specification standard. Irrespective of how you do it, once you have the spec here, this spec is what is defining your API. And there is a producer lifecycle that goes in here where you are creating this API in your containers and your VMs. You have source control, you have SDLC that is that this API implementation goes through. And there's a consumption angle where your developers will try to consume this API. You need to provide them interactive documentation. You need to give them the details of what this API is all about. In both these areas, there's an aspect of Postman. If you're prototyping, we'll do a quick demo of that. And if you're developing an API, we'll do a quick demo of how you can use Postman in your SDLC, test the API across your lifecycle stages. And finally, once this API goes into a portal, there again, you can point them back to this collection that is defining the documentation of this API. So with that, I'll hand it over to Garrett to walk us through the platform and show how some of this can be built in action.
Wonderful. Thank you, Sandeep. So we're going to start in Postman, and we're going to start in a workspace that's public. So you all can navigate to this if you search on the top here. And we've put this out for you to come back and reference when you need to. So what we've done is we've created a collection called the Payments API. And this is a good example of actually collaborating with your team members and developing an API together, right? So what I've done is I've actually added an example response to our endpoint, this create firm request. And what I'm going to do is I'm actually going to navigate, pause, that was not supposed to happen. So what we're going to do is we're going to navigate into that create firm request. And you'll notice here that we have an example response here, but our base URL is completely empty, right? We have not written or implemented this API, but I still want to collaborate with Sandeep on this. So what I'm going to do is I'm going to open the comment mode, and I'll notice that I have written a comment tagging Sandeep, and Sandeep has actually applied referencing this username variable. right? So, the payment source variable, right? So if I click on that payment source variable, now Sandeep and I are collaborating on this API design. So now I actually want to go into the request and press that send button, right? I want to be able to call something that gives me a response. So what I'm going to do is I'm actually going to click on the actions drop down here, and I'm going to press mock collection. I'm going to give it a name, payments mock. I'm going to save the mock server environment URL to a new environment. What this is going to do is it's going to create an environment for me. The collection uses the name base URL, so I'll just switch the variable name. But you'll notice that I actually have a mock.postman.io variable in my collection. Now what happens is, if I go back to the request and I switch the environment to payments mock, you'll notice that the base URL is now filled in, and I can press send request, and I get a response from the Postman mock server. So what this does is it creates an interactive environment for Sandeep and I to actually collaborate on things. And you'll notice something, you'll notice that I actually have failed tests, right? So now we're going to navigate into more of the testing side of Postman. So I have some failed test results here. Let's look at what they are. It's expecting a certain payment type, and it's expecting a response time. So let's do something about that payment type value. So right now it's accepting a debit or credit value. And if I navigate to my test tab, you'll see that I have a test written here that expects my response to have one of these values. Now, if I go to my example response, you'll see that payment type is transfer. And this is not an accepted value, which is why my test failed. So what I'm going to do is I'm going to switch this back to debit. I'm going to navigate back to my request. I'm going to send the request again. And you'll notice that all my tests pass because the payment type has been updated in my mock server. So mock servers are an amazing way to collaborate with your team members, right? Sandeep can also choose the payments mock URL. And then we can all work together. We can design this API. And then what we can do with this collection, which Sandeep mentioned earlier, is we can actually generate an OpenAPI schema from a Postman collection. So Postman has a utility in our public workspace, which you can additionally search for, that actually takes a Postman collection ID and it converts it into an OpenAPI specification. So now, what are we going to do with that OpenAPI specification? If we navigate to the APIs tab here, this is where the payments API specification is actually uploaded. And now we're going to go into another Postman testing feature, which is called API governance. Now, what will happen is my definition file will load from my remote repository. My definition file will load from my remote repository where the definition is stored. And you'll notice that I actually have an error here that all of my operations need summaries, right? So this is a rule that people on my Postman team have set that said all of your specifications need a summary. So you'll notice that the second that I add a summary to this, my rule violations are gone, okay? And so if I remove that summary, you'll notice that my rule violations show I have an error. So this is going to be on the API governance side of Postman, which actually allows your organization to create consistently correct schemas and put your own logic in it. So now I've shown a little bit about API governance. I've shown how specifications can be incorporated into Postman. Now what I'm going to do is I'm going to go into that API that I've uploaded. You can see I have the same collection here as well as my definition. And what I can do is I can additionally hook up CI/CD. And so the question is, what do you use Postman CI/CD for? Postman actually allows you to run collections as part of your CI pipeline. So you'll notice that this collection is linked to my API, as well as I have GitHub Actions connected. And this is done through OAuth GitHub flow. So what I can do is I can actually copy this Postman command, this YAML file. I can use it in my GitHub Actions template. And as you can see, what it's doing is it's actually running a Postman collection. And so before I actually merge code to the master branch, I can run a Postman collection. I can validate that those tests pass any business case or logic that I need. And then I can either fail or pass the build pipeline depending on that collection run. Additionally, you'll see that we can actually do the governance checks that I did in this definition tab as well on CI/CD. So from the presentation, we started developing a brand new API inside of a collection. We mocked it so that Sandeep and I can collaborate together. We converted it to an open API specification in order to generate code or generate collections or mocks or monitors. And then what we did was we hooked up CI/CD and went full circle on the testing lifecycle. So this is Postman from design to deployment, testing, iterating, and collaborating inside of the platform.
Awesome. Thank you, Garrett. So these are a couple of demos we wanted to show you. One, how you can leverage the prototyping within Postman as the baseline for generating your microservice. And once you have the microservice, how then you can use Postman to eventually integrate with your CI process along with your microservices development. And finally, as the API becomes ready for consumption, obviously all the collections that you have created, all the documentation that you have within Postman can then be leveraged to make the consumption experience a lot smoother and easier for your API consumers. So thank you for joining. We do have a couple of additional resources that you can use to learn a little bit more about Postman. But more importantly, this QR code and this short link will take you to the public workspace that Garrett used for the demo. And in that public workspace, we do also have a lot of documentation, especially on how Postman is relevant for an Azure API management user, or like if you're in the Azure ecosystem, you're developing your microservices in Azure, we have listed some use cases here. We'll keep iterating on this public workspace. Do let us know if there is feedback. We would like to work with you on improving how the messaging of how you can use Postman with Azure. Thank you all. Have a good day.
All right, everyone, we're keeping APIs in action going with awesome sessions. We are just a little bit over halfway through, and Massimo is back with another session, this time taking a look at how to build a warp speed time to market API with DAB, APIM, and Azure Container Apps, all the goodies in there. Massimo, take it away.
Welcome, everyone. The session today is about building an API using DAB, API Management, and Azure Container Apps. Let me start from the story of DataSprint. DataSprint is they have a very classic need. They need to exchange some data with their business-to-business partner. And but today they are using an old way to integrate with their partners. So they use you can imagine the classic flat file system. This means that every time they have a new partner, it's a time-consuming task. They need to integrate with the partner, for example, because they have someone that needs this file via SFTP, the one with FTPS, etc., etc. So not only for new partners, but it's also time-consuming every time that they need to expose a specific set of data, so a new view. So they want to invest this time not in integration, but they want to focus on new feature, on new way to exchange in a way modern way. Okay, so that brings me to the goal of DataSprint. So they want to surface these data sets in a secure way, in a performant way, and in a scalable way for their customers. On the right, we do have their starting point and some requirements. So those data they want to surface are already available in terms of SQL views. They are ready to be consumed. So the way to interact with this data is read-only. So no needs to create data to perform changes on these data sets. They are looking for an interoperable format, so a format with a large ecosystem. You can imagine REST APIs. It fits good for their use case. It's mandatory, extremely important that data is secured, so secure access, for example, going via Entra ID. They do want to avoid for every new views or every new partner development cost, and for their developers, they do not want to have a steep learning curve, so no need to use Kubernetes and that kind of complexity. They want something very simple. That brings me to the approach for this use case. So we decided to approach it with the PaaS first. Why PaaS? Because we can do more with less. And we will look at this problem from three dimensions. The dimension of fast innovation. So to make sure that we can leverage the Azure power, those pre-built services that Azure has, to make sure we can go fast. We want to optimize the cost. So we want to configure efficiently our APIs, our endpoint to not spend more than needed. And then we want to operate with confidence, meaning to empower developers to use the right tool for better security, resiliency, performances, and so on. So with this in mind, this three steps approach, let's start with the first one, so with innovate faster. Here we just look at Data API Builder. So Data API Builder known as DAB. It's something that has been open source in 2023. It's an open source tool launched by Microsoft that allows you to turn very quickly a view, a table, a store procedure, or a collection from Cosmos DB very quickly into a REST or a GraphQL endpoint. It supports a full pagination, sorting, filtering, and so on. So you don't have to build from scratch all of these utilities that helps you to interact with data. It works today with 4 types of repositories. So with SQL, Azure SQL, or also Azure, SQL on premises, if you want, Postgre, MySQL, and Cosmos. It is built with security in mind. What does it mean? That even if it allows you to expose a database, it's not going to expose the full database, but just only what you need. And you can integrate with Azure Active Directory and OAuth 2. And you can also leverage some authorization via DAB policies, which extract a claim, for example, from your JOT token and filter your SQL data by using the JOT token. It also allows an easy deployment modus because it's distributed as NuGet package and is also there as containerized image. How does it work? DAB, it can start with 2 things, just a configuration file and a connection string to your database in the case of REST. And for GraphQL, you need still the configuration file and the schema that describe your objects that you're going to expose. Then there will be an in-memory abstraction, and then of the schema of this configuration file, and then it will be translated into a REST endpoint. So you can, from your consumer point of view, you can just go and fetch the data via this REST endpoint. So that's how it works in a nutshell. How to use this tool? You can just use the .NET tool installer with Microsoft Data API Builder. Then you need a connection string, and you can use the DAB CLI to initialize the configuration file where you can define which entities to expose. That's the next step. In this case, DAB add special divs. That's a view that we want to expose from our SQL database in this case. And once you add only that entity, or with multiple DAB add additional entities to your configuration file, then by using DAB start, you can just access via a REST endpoint, in this case, to your database. So one of the things here, when you expose your database, so make sure that you don't directly expose your model to the outside world. That is clearly an anti-pattern for multiple reasons. Some of those reasons are here in this list. But this is in general for every technology. Take the time to understand how to use and how to avoid the misuse of the technology. In our case, everything, our views are already ready to be used to the outside world. We selected the field that we want. We are sure that the data types are the one that we want. So everything is ready to be consumed externally. So no worries for this very well-known anti-pattern. Okay, let's just quickly check a demo of DAB. So I'm starting here with to expose a table in this case. I just use a little configuration file. Then I need to install the DAB tool. In this case, I update it because I already installed my machine. Let's see this running. Voila, we are running the version 0.10.21. Then I do create with this command dab init an empty configuration file that use my connection string. The file is added here. There is nothing special except the connection string to my SQL environment, and everything is empty. I'm saying here that I want to use the development mode. We will see in a while why this. And then I go back to my table and I want to add one view. And I say that I allow, for this example, the anonymous access. So this special deals has been added to the configuration file. Here we are, what I want to show. To add, and then as a final step, I can run my dab start, and dab will take care of, let's say, create this public endpoint. You can see that is starting up. Now my dab is running at localhost 5000, so I can then go and, in this case, just get all the special deals. You can see here it's coming back everything from my database. I can check here on the logs because I'm in development mode which kind of query has been executed. I can get a specific deal with this notation, the number one. I can go and filter. In this case, we're using discount percentage. I can select some fields, only the one that I'm interested in, and so on. This is what very quickly the DAB allows me to do. Now, let me go back to the slides. Okay. And let's move to the other part, what about optimized cost. So now I have these APIs or this data API on premises, and I need to make it available to my customers. So I said that I can use, we can use DAB as a container. So we can, the easiest way to host a container in Azure is using Azure Container Apps. It's an offering that abstract all the complexity of Kubernetes, and it's really extremely simple to run. So what do I need to run a DAB? In this case, I need to have an Azure Container Apps environment here at point one. Then I need to, because DAB is working on based on the DAB configuration file, I need to add this configuration file to the storage account and link the storage account to the ACA environment. So my Azure Container Apps application can fetch and mount this file and use this file. So why, again, Azure Container Apps, I can focus on my application, and the infrastructure is extremely simple. And then because Azure Container Apps leverage KIDA, I can scale to zero, so pay nothing if I don't, or really a small amount of money if I'm not using this that view in this case, or that endpoint. So in this case here on the left, I set up the infrastructure, I set up the environment, I create the application, and then using a specific convention in my script, I can host 0 or 1 customer. So, but then we said that we have our use case, our rapid data company. They do have multiple customers. They want to expose the same things in a different way, and we want to keep the cost under control. We can leverage, we can create one endpoint per suppose customer or per view. In this way, we can scale dynamically based on event. So if the customer endpoint is used more, I can monitor the requests that are hitting that endpoint and scale up, for example, up to 3 if I have more than X HTTP request, concurrent request. And then I can decide that, for example, special deals are not used so much, so I can scale to 0. In this way, I can control the cost not only per view, but also per customer that uses a specific view. This is very simple because I'm using the same convention as before and just use few parameters to decide how many endpoints I do have. And then the next step is like, okay, there is something wrong at a certain point of time because we are having too many endpoints. So this means a bigger attack surface is complex to consume and it's also complex to maintain. You can see here at the bottom, if with this approach and container apps, I will have a very complex URL to be given to my consumer. With this in mind, what can be the next step to simplify and making this setup more secure is just to see which kind of tool we can give to our developers to have a better secure and less complex setup. So in order to do this, what we can do to achieve, to make it more secure and more manageable, we can turn our Azure Container Apps from public to internal, so will not be anymore accessible from the internet. And we can put something on top of our, in front of our Container Apps, in this case, Azure API Management. For this little example, I also host Azure API Management in Azure Container App, so I'm leveraging the self-hosted gateway of API Management. And then I can also, by introducing this design, I can decouple the public version that is controlled via Azure API Management with the internal version that is controlled, that has a different life cycle. With this setup, it's really, voila, I just give a single endpoint to the consumer that is called, in this case, ingress. And then I can, with this facade, maintain the 2 different life cycles. So I can also expose which operation, decide which operation to expose and which one not. I can also implement throttling. I can implement throttling at API management in this example. I always advise my customer to implement throttling in a different way. So throttling some configuration in case of successful request, but even throttling harder in case of error. I can implement resiliency at 2 sides, one on API management backend or on Azure Container Apps, leveraging the resiliency policies that has been announced a couple of months ago. And then I can implement, also using API management policies, I can implement policies that mask internal details, so we are sure that what's happening downstream are not surfaced back to our consumers. So what happened then? We end up, so we move from a situation where we have multiple HTTP methods, multiple endpoints exposed, with a solution more easy to maintain, also easy to consume, and also more secure that we have on the right. So we expose only the view that we want, the method that we want. We give the flexibility to our customer to fetch the data in a secure way as our customer is requiring. So that brings me to the takeaways of this session. So we were able to quickly expose a data API using DAB. We turn a SQL database very quickly and fast in a REST endpoint. We were able to keep the cost under control to have a multiple configuration per customer and per view. We can scale to 0 if needed. And then we secure our endpoint using the power of API management and the power of resiliency policies introduced by API management or Azure Container Apps. That's everything for today. Thank you for attending this session.
Welcome back to Azure APIs in Action. If you haven't, make sure to subscribe so you can get notifications of all of our awesome content, as well as post your questions in the chat to make sure you get all of your questions answered. We have experts in there, and we want to make sure you're getting your answers. Next up, we have harnessing the power of Azure API Management, building robust and secure API with Hamida.
Hello, I am Hamida Arbey. I am Microsoft MVP in Developer Technologies and also MCT. I am Cloud Solution Architect and Docker Captain. Today, we will talk about how we can harnessing the power of Azure API Management. We would like to build a robust and secure API. We will start talking about the API requirements, the different challenges where we are faces. After, we'll talk about the different advantages of using an API management platform. In the next section, we will talk more about API management and the different features. How to build robust, secure, and scalable APIs is the third part. And in the end, we will share some best practices to secure your APIs. Let's start now. In today's digital landscape, APIs play a crucial role in connecting applications and enabling seamless interactions. APIs now play an essential role in modern web and mobile application architecture. Data management, business integration, IoT interaction, enterprise application, and microservices architecture also. The use APIs follow the same path to innovation as websites. APIs have become an integral part of software development, allowing different applications and services to seamlessly communicate with each other. However, as companies increasingly rely on APIs to streamline their workflows and enhance their products, they are also encountering several challenges in API integration. To engage in the API economy effectively, addressing several requirements and challenges related to monitoring, managing, and securing APIs is imperative. It includes the reuse, because we need to integrate legacy APIs without the need for expensive rewriting, enabling a smooth transition and integration. Access without a headache, because here we'd like automate the process of providing developers with easy and intermediate access to the API. This will reduce administrative complexities. Security is really important to secure our APIs, our platform that will manage our APIs, to ensure the robust security of backend system and implementing measures to protect APIs against unauthorized or excessive use, safeguarding sensitive data, for example. And we need visibility, because we need to establish mechanisms to measure and monitor API usage. Why? Because we need to understand which APIs are in operation, the extent of their use, and identifying the parties involved. Successfully addressing these aspects is vital for creating a seamless and secure environment that encourages API adoption, fosters collaboration, and maximizes the benefits of participating in the API economy. But how we create this API, how we can support APIs? Companies releases APIs bear the responsibility of systematically advancing them. It's crucial to acknowledge that when developers use a published API to code programs, any substantial changes to the API require rewriting their programs, avoiding the imposition of modification to applications with every API change. IT organizations frequently opt for simplified facades. These facades effectively decouple the internal implementation from the API consumer experience because it offers streamlined API tailored for specific use, allows IT organization to modify the underlying implementation without affecting developers' application. So what is the role of this facade? It enables transformation and enabling IT organization to support legacy applications. Legacy APIs like XML, SOAP, for example, with never newer standard like JSON and REST seamlessly, without the need for recoding or reworking the original API. So the efficiency gained through reuse often justified investing in an API management platform. So what is an API management platform that will help us to create these facades? An API management platform is a robust software solution crafted to streamline the entire life cycle of an application programming interface, API. So this platform offers a suite of tools, functionalities tailored to support various phases of API development, deployment, monitoring, and maintaining our APIs. It encompasses features such as API design, documentation, security, and access control, traffic management, analytics, and reporting, versioning, and lifecycle management. It includes also developer portals, monetize capability. By leveraging an API management platform, organization can efficiently create, publish, manage, and secure APIs, thereby enhancing interoperability, scalability, and developer experience while maximizing the value of their digital assets. So in the heart of an API management, it acts like intermediary between the API and the users, whether they are customers, they can be partners, they are developer, instead of interacting directly with the underlying services. So developers connect to the API management layer, which furnishes all what we need as functionalities to save successful and to build scalable API use. What is the tool that we are able to use in Azure? So what is the platform, API platform that we are able to use? So Azure API Management is our platform that will include all these features. So let's take a look about what is Azure API Management. So this system is made by three, let's say, components. We start by the first one, that is API Gateway. That is the endpoint will accept API calls, it will route them to the backends. It verifies the API keys, different tokens, certificates, and any other credentials, because we need to secure our APIs. We need a platform that will manage the security of our APIs. It enforces usage quotas and rate limits. It transforms your API on the fly without code modifications. We have catches backend response where set up because we need to improve the call. So we create catches here. And we need to monitor and add the logs. So in API Gateway, we logs call metadata for any analytic purpose. And Azure API Management is in hybrid mode because we are able to create a self-hosted API gateway internally. So you are able to manage your internal APIs. It's not only for external APIs. So with self-hosted management, customer can deploy the API gateways to the same environment where they host their APIs to optimize API traffic and ensure compliance with local regulation and guidelines. The self-hosted gateway enables customer with a big environment, hybrid IT infrastructure to manage the API hosted on premises and across clouds from a single API management service in Azure. The self-hosted is a package, is as a Linux-based Docker container. It's really simple. You can create one container for your API gateway internally, and you can use also Kubernetes. It's one container, so it's really simple to set a self-hosted API gateway internally. Another component that is really important, that is Azure Portal. Azure Portal is the administrative interface where you are able to set up your API program. You can use it to define or import your API schema, package APIs into products, set up policies like quota or transformation on the API. You are able to get insights from analytics. You can also manage the different users internally. This is related to the admin IT. We have another portal, we call it the developer portal, that serves as the main web presence for developer, where they can read the API documentation. They are able to try out an API with interactive console. They create an account and subscribe to get API keys. Here we have the security part also, and we can access analytics on their own usage. So our API management platform, it includes, let's say, two planes. The first one is control plane. Why we call it control? Because we will control the use of our platform using two portals. The first one is the developer portals that we already described, so we can use it to discover onboarding of API within an API catalog on marketplace. We can access to documentation. So we have different features inside the developer portal. The second portal is the admin portal, is Azure platform portal, where we can add API to the API catalog, configure our API products, manage security, traffic monitoring policies. The second plane is the data plane, because it can include the API gateways. It's the place where we will add our APIs, where we interact with our APIs. So, as we said before, we have two ways. We can deploy our API gateway in Azure remotely, so in the cloud, or we can deploy it internally using the self-hosted on-premises service implementation. The administrative portal and developer portal are integral to the control plane in this case. When an API gateway data plane is deployed, it registers itself with the control plane and retrieves relevant policies. So during runtime, the API gateway operates independently of the control plane for enforcing API request policies. However, it does receive policy updates and reports API usage metric and monitoring data to the control plane when feasible. Since communication with the control plane is asynchronous, the API gateway must be resilient to intermittent control plane availability or connectivity issues. So this specific architecture of modern Azure API management platform allows a single control plane to configure, manage your API gateways deployed across multiple cloud services provider. So we can have another part, we can deploy it in another cloud provider, the API gateway. So how we create and build robust, secure, scalable APIs. So we have our platform that will allow us to secure, to do analytics, to interact with different customer, user of my APIs, but we need to ensure that our APIs is really robust and secure and scalable. So delivering APIs is a critical task for an organization using modern application and integrating architectures. They provide a foundation on which to create a successful composable application architecture where partners, clients, and stakeholders interact through specific software. To ensure the APIs you deliver are valuable for the developer, integrator, and integrator using them, you must ensure that these APIs are sustainable. In other words, You must ensure they remain useful, secure, stable throughout their life and the life of the apps and processes that consume them. Providers of APIs deliver interfaces that provide access to functionality and data in a way that should be easy for API consumers to use. API consumers are developers who use an API's functionality to create new business solutions. API consumers rely on the APIs they use being secure, performant, stable, and available for the lifetime of their applications. Poor API delivery has far-reaching consequences. Why? Because for both API providers and API customers, we need to have the higher delivery and maintenance costs. We have poor consumer experience and loss of revenue in this case. You can miss business opportunity through lower productivity and slower delivery. And you can increase the risk through poor security and identity management. This raises the question that ask how to deliver and how to support APIs and how developer can build robust and secure scalable APIs to be able to build valuable solution. This is the goal. So we consume APIs because we need to build specific solution, valuable solution inside an organization. So we have a platform that is really based on the consumer-centric approach to harmonize service implementation, architecture, and API lifecycle. So we need to ensure APIs are secure, available, and really well supported. We need to have always the documentation of the APIs, one for recommendation to when you create as a developer, we create an API. This approach contrasts with a bottom-up, provides a centric perspective by prioritizing the needs of API consumer rather than the viewpoint of the API provider. So we need to focus solely on the provider perspective, often leads to the creating of specific APIs that can serve as a simplest abstraction layer overlaid on an existing domain module without sufficient input from consumers, potentially compromising encapsulation and fostering coupling. So you can form a part of a set of services, model, consulting in direct access, and tie coupling to the domain model, leading to an desirable dependency, also known domain model dumping, for example, here. So you need to create an API that fulfill the requirement of consuming developer. Specifically, it should provide necessary and relevant functionality, offer clear definition in technical and non-technical contracts, be thoroughly documented and easily comprehensive, be well implemented to meet both business and consumer needs. We need also be able to test performance. It should be reliable, accuracy also. We need to ensure ease and consistency of implementation for consumers and be discoverable with transparent versioning, bug fixes, for example, because we know that bugs it comes with APIs with any solution, but we need to have a clear vision about that with a specific version and support monitoring and analytics to uphold quality and availability, implement consistent security measures and access control. We will see how to do that in Azure API Management also. So let's see what are the best practices for security. The first part is implementation of authentication and security, which means that we need to implement access control for your platforms, administrative, followed by the security infrastructure that will protect both the platform and your APIs, because we need to secure the platform and the APIs. Not only is every API a potential attack surface, your Azure API management itself is a target for attackers also. So work closely with your security team to secure your platform as you link your platform to your authentication and authorization system. So you need to link it to that. Lock down all other access, ensure that default administrative access account are removed, for example. You need to ensure you have multiple verification to do with your security team to ensure the security of your APIs, your security of the platform. You need to ensure that your DDoS protection will shield your platform, for example. If you use, for example, a CDN, ensure that you have correctly configured its cache policies to work with your APIs. So you have multiple things to do to secure your platform with authentication authorization, also with your APIs. So you need to check all these elements when you start adding your platform, API platform, Azure API Management in our case, and when you start creating and building your APIs. Another element that is configure endpoint protection capabilities. That's one of the most critical capabilities of API gateways is their ability to provide protection for API endpoints. So we have two types of endpoint protection capability, the rate limiting and throttling limit access to an API endpoint, while circuit breakers protect both of API endpoint and its consumer from any failure. Don't forget, if you are in hybrid environment, don't forget to implement an API mediation. Your API gateway is the starting point of your API mediation. You will use it to enforce security and access control policies and to monitor and manage traffic to your APIs. You will also do some amount of transformation in your API gateway, such as converting, for example, XML data packets to JSON. Use caution when implementing transformation in gateway, doing, for example, some both burden the gateway and create lock-in in your current vendor. So you have multiple things to do to implement an API mediation. If your Azure API management is deployed internally on premises in your sites, and you publish APIs from on-premises system, you should prefer an ESB, DIP, or custom mediation located on premises. But if it's really deployed in cloud, it's hosted in the cloud in Azure, you can publish APIs, for example, from on-premises system. You can either choose an on-premises solution or use any infrastructure platform as a service as a mediator. If your Azure APIs management will just publish external API, in this case, you can use what is inside as a feature inside Azure platform, Azure API management. The last one is to configure analytic and reportings. We need to do that not only for Azure API management, but with any other services inside Azure, because it's really important to have analytics. Analytics and reports are critical tools for understanding how your platform and the APIs it publishes are performing. So they also provide valuable evidence for key stakeholders that your platform and its APIs are meeting expectation and can identify cases where it's not. The data produced by your platform is useful to many audiences, and you should ensure that all of them are getting what they need. For example, if you are monetizing APIs on a per call basis, then you will need to provide access to information on usage and costs to the developer who are consuming your APIs. This will allow you to understand and manage their costs. To secure our APIs in Azure API management, we can use subscription. You can secure them by subscription or by certificate. Subscription keys or plans, how to access the policies inside the subscription, monitoring analytics. We can find them in subscription and certification. If we use certificates, how we can manage that, where we are able to store them in Azure Key Vault, not in Azure Key Vault, internally, externally, using another tool, or configure API management policies. Let's start by the first one, some best practices about securing your API using your subscription. When you publish APIs through API management, it's really easy and common to secure access to those API by using subscription keys. To get subscription key for accessing APIs, a subscription is required because we need to link our API management to the subscription. And the subscription is essentially a named container for a pair of subscription keys. Subscription key is a unique auto-generated key that can be passed through in the headers of the client request or as a query string parameter. We see that here. So as you can see here, when you have create your API management, you go to subscriptions and you can find the primary key. You have two types of keys, so primary key and secondary key. And you are able to generate them anytime. So if you have any problem of using these keys, you are able always to generate new keys and reshare again the keys with authorized APIs. And the keys can be passed by the request header or as a query string in the URL. As you can see here, you can get the primary key, secondary key, and you add it in the request header. And you can do that in website, by code, in another tool. For example, if you are using a specific platform that will consume your API, so you can pass the key in the header. For certificates, how we can use certificates? Certificates can be used to provide transport layer security mutual authentication between the client and the API gateway. So you can configure the API management gateway to allow only requests with certificate containing a specific thumbprint. The authorization at the gateway level is handled through inbound policies. It's really simple with certificate also. For example, here for APIs, you are able to configure your policies, how you can get. So this is operation, for example. I have an API demo that I'm using it. And you can accept client certificate in the consumption tier. You have certificate authorization policies. You are able to configure it. You can check the thumbprint of a client certificate, and you check the thumbprint against certificates uploaded to your API management. We have multiple ways to add policies, to add your certification, to add your authorization to your certificates. Thank you, and if you have any questions.
Thanks everyone for continuing on with APIs in action. If you just joined, there's tons of goodies. You can go back and rewind, but of course, all the videos will be right here on the Azure Developers channel. So make sure you subscribe as we put out those videos throughout the next few days. All right, next up is Tom looking at how to build a resistant API landscape with Azure API Management. Let's hear from you, Tom.
Hello, everybody. My name is Tom Karkova, and I am a senior software engineer on Azure API Management. And today I will talk about building a resilient API landscape with Azure API Management. In this day and age, we see that the digital transformation is building on top of APIs, which means this is a super essential part in your platform because it can become a single point of failure. So we need to make sure that this does not become a problem for your business. In this talk, we will see how Azure API Management can help you build a resilient platform. But first, we need to have a look at Azure API Management as such. It has three main components, which is the developer portal, management plane, and the gateway, which we also refer to as the data plane. The most crucial part of API management is your data plane, This is where your live traffic goes through. But of course, you also need to make sure that customers can still explore your APIs and that the platform teams can still maintain and configure the APIs that they expose. So there's a lot of burden on us to make sure that we do not have any problems. So I will show you some of the aspects that can help. And first of all, we need to design for failure on the infrastructure level. With that, I mean, we need to make sure that all these units and these machines that are running under the hood are running highly available. And that can be easily done by using availability zones, which make sure that all your units are spread across the region and avoid having failure when a single data center goes down. This highly increases your SLA as well and is available in premium tier and all AZ-enabled Azure regions. Secondly, as your business grows, your traffic will also grow, and you need to make sure that you can keep up with the load. And this is where auto-scaling the gateway and the platform itself is crucial. This is also available as a platform as a service through Azure Monitor Autoscale, which is just a couple of clicks to set up, which helps you meet that demand, but also helps you be cost efficient to scale back in when the traffic is slowing down. And we live in a global world, which means there's multiple regions. We want to make sure that a regional outage does not impact the whole platform. We want to make sure that our gateways are running as close to your customers as possible. And this is where the secondary regions come in. You can use one Azure API Management instance and deploy them to multiple locations to meet the needs of your platform and to reduce the risk when a data center goes down. Even bringing a gateway closer to your customer can also increase the speed because you get faster into the Azure backbone instead of going over the public internet. And of course, when you design for failure, you also want to test for failure. So you can do chaos testing by disabling gateways in various regions and see how your traffic pattern reacts to it. This helps you simulate Azure outages in certain regions and test how it reacts. And in this case here, you can see what it looks like to have an API management instance with two regions, where when one of your customers send a request to, in this case, contoso.azureapi.net, it is using Azure Traffic Manager actually under the hood to route traffic to the nearest region and the nearest gateway to send the requests. If one of those regions would go down, the traffic would automatically fill over to any of the other available regions. And this is how you can easily use these secondary regions, for example, to mitigate these issues. So let's do a quick demo and see how easily you can set those things up to make sure that your infrastructure is ready to mitigate these problems in the future. I have here an Azure API Management instance, which has the premium tier. And let's start by adding or seeing how you can add multiple secondary locations of the gateway. So on the left, you can see there is a locations section where you can add multiple units. In this case, I already added 3 secondary regions where you can add multiple units. And in this case, you can see that Southeast Asia is actually using 3 availability zones. If you want to add more, it is just as simple as selecting the location. For example, let's go to Australia, and you can add availability zones. Do note that if you want to add availability zones, you need to make sure that this meets the amount of units that you have. So in this case, we want to have 3 availability zones. We want to add the unit and then click OK. Once you did that, we are already present in multiple Azure regions. However, there is a caveat that when you go to secondary regions, you will only provision the gateway and not the control plane and the developer portal. So that is important to keep in mind, which is why it's called a secondary location and not a primary. Second is the instance provides metrics on how is your gateway doing. This is the capacity metric, which is sort of the most important one to see how much capacity you still have. In this case, you see I had a peak here of 45%, but on average, it's very quiet. However, when you're doing multi-region scenarios, you can also see the usage by region here in this list, which is important for your monitoring purposes, alerting purposes, etc. Now, in order to make sure you have enough capacity, you can use the Azure Monitor Autoscale integration and either use the manual scale or use the autoscaling option. In this case, I have configured two rules to scale out when the capacity is above 70% and then add one instance. If it has been less than 40% for 10 minutes, then decrease the unit by 1. And this allows you to react to how your traffic pattern is doing. If you're using application insights to monitor your APIs, which you can simply add here, you can basically see the traffic flowing across your regions as well. So if I go to this instance and select the application map, you get this nice visual where you can see my one single instance and the secondary locations. You can see the average response time, how many calls it received, and where the traffic is flowing. So if I would have different backends by region, this would also be reflected here. And lastly, every API management instance has a domain name. So what we can do is, of course, we can send health probes to this instance. For example, when I do a curl, there is a default endpoint that sends me if the service is still healthy. But when you're using multiple regions, it is always nice to be able to see how it reacts in that same region. So in this case, let's talk to Southeast Asia. And let me first verify that I have the region correct. Southeast Asia, and when I sent the same request, you can see that I get a 200 OK back as well. So this not only allows you to send health probes, you can also, for some reason, send direct requests to these specific endpoints if you have the need. Let's go back to the slides. So we've seen how we can use multiple regions, how we can auto-scale to make sure you have the capacity, how we can use availability zones to make sure that the compute is spread across the data centers and the availability zones in the region, and how you can use application insights to also monitor your traffic pattern. So let's look at the application side of things. And how to protect your backends as well to make sure you are not overwhelming them. So you can prevent abuse by using policies such as rate limit, quota, and limit concurrency. You can use circuit breaking to make sure that once your backend is having problems, that you stop sending requests so that it is able to recover. You can also use load balancing to make sure that you distribute requests across multiple backends. And you can use retries to make sure that if there's a transient failure, you can just retry that failure. So load balancer is available in public preview. It is a new type of backend that basically allows you to point to multiple other backend services. It is a very easy way and you no longer need to write your own exotic policies to achieve this, which I will show in the demo. Secondly, Circuit Breaker is also a new feature in public preview that allows you to define that criteria that I mentioned. And when that criteria is met, the circuit will be open and we will stop sending requests to your backends as well. So I always say talk is cheap. So let's quickly see how this works in action. So I have here a ARM template, which we saw in the slides. And basically, we just give it a name, which is called Products Load Balancer. And I basically pointed to two separate backends. Once you have this backend created, you can use a policy to just change the backend and send all the requests to this load balancer. So I already created these backends, which you can see here. So I have this monolith, products API, and the load balancer. So now if I go to my APIs and basically go to the products API and then edit the policy, paste this in, and click Save. I can now start calling this backend on this URL, and I get a response. I also have a policy on the all APIs level, which is giving some information. For example, this request was sent to this backend URL. In this case, the monolith. If I do this call a couple of times, we will see now it's going to another backend. If I do the call again, it's going to the monolith, etc. So just by creating a backend and having these two backends defined to which it should send the requests, it's doing it out of the box with just changing the policy, point to the new load balancer backend and send the requests. Everything happens for you. If you use the debug, the trace API capability that you have, you can also see this in detail. If you want to do load balancing based on the region that is being called, because sometimes you want to send it to a regional backend, you can also use context properties such as this scenario to change the backend service. Circuit Breaker works very similar. So you give it a backend URL. In this case, we define that if there are 5 failures, which are defined by status code 500 or more, this is considered to be failure criteria, and it will stop forwarding the requests. After the period of time, which is in this case 1 minute, it will then slowly send requests through, and if it's fixed, it will happily send requests through forever. In this case, I have the same policy to change the backend to my new Circuit Breaker backend. And I added some additional headers to show that if there is a failure, you get more information. So I'm going back to my APIs again. And I have this Bacon API, where I will apply this. And in this Bacon API, I have a small header that I can add, which basically says, add chaos to always fail the request. So because I'm now using the Circuit Breaker backend, I will get 5 failures, 3, 4, 5. And now you see that the circuit is broken. It is giving me temporary unavailable with the name of my backend. And because I added these additional custom headers in the response, I can see where it failed, why it failed, what the message is, etc. So both of these features are available in public preview. Give them a try and let us know what you think. So let's go back to the slides and wrap up. Thank you very much for joining. So hopefully you've learned how to protect your infrastructure and also help you on the application side to prevent being impacted by any outages, hiccups, and be able to recover faster to avoid having any business impact. Thank you for watching.
All right, we're back with Massimo again for our third time today, and we're so excited to hear your session on Enhance Your API Security Posture with Microsoft Defender for API. Have fun, Massimo.
Welcome, everyone. I'm Massimo Crippa, and today in this session, we talk about API security and Microsoft Defender for APIs. So it's been more than 10 years that modern APIs are booming, literally booming. And today, they also became business critical, for example, to move fast and innovate, to automate business processes, meaning to operate efficiently in our company, and to be, let's say, customer-centric. So those modern APIs are literally everywhere. And more APIs, the bigger the attack surface is. So when we look at all of this data passing and moving through APIs, we can also understand that we have more and more data breaches, so more attacks in all of these years, and also as a source security report says here, APIs became also a significant business issues in the sense that 59% of enterprises experience delay in rollout because of some security issues. So it's very extremely important. Security for every enterprise. Security became the first concern of every enterprise. So when it's about the security, there are mainly the two parts in a DevSecOps cycle. The preventive part, so when you start planning and build and before going to production, and then the runtime part when it's about the deploy, operate, and monitoring the workload that we put into production. So it all starts with threat awareness, meaning understand what are the potential threat of our workload. So using, for example, Stride models to understand which components we have top-down, describe them, understand the data flows and security issues when PI is used and so on. So that's the beginning. It's also important to have in our company threat awareness and teach our developers and architects with some secure by design architecture. Then we move on in the build where there are, for example, static analysis tools, and that's normally what is used the most by our developers. You can lint everything. You can just do dependency management, credential scanning, and so on. So all of these things are very good practice, especially when you commit your code. So then we move on with the part of testing, deploying our workload in development, acceptance, and so on. Over there, we can start using OWASP zip, for example, so to test the security against something that has been a workload, an application that has been deployed. And then we move on to production. And once we are on production, we need to operate and monitor our workload. So, for example, which kind of security patches we want to we have to apply, the access management, and so on. And then we end up with the workload protection at the end of this post-production security focus. And that's where we want mainly the right side that we want to focus today by looking at Defender for Cloud and one of the offering into the Defender for Cloud, in the Defender for Cloud, which is Defender for APIs. So then I was saying, and once we start operating our workload, we need a tool to continuously, let's say, assess, secure, and then defend our workload. So here, Defender for Cloud gives the major tool to take care of the DevOps, to take care of our security posture, and then to protect the workload. On top of on Defender for Cloud, we have all the integrated insights that are surfaced by the tool, and then we have all the integration with, for example, CM, Sentinel, or any other CM you might use. We can leverage then the workflow automation to, let's say, manage the security recommendation that has been surfaced. We can create security workbook and so on. So that's mainly the integration at the bottom. So this is the Defender family. We will look in the detail Defender for APIs for runtime security in API workload, which allow us to discover the API that we have, understand the catalog of the API catalog and their security posture. We can put in place security control to protect our configuration. We can detect the suspicious behavior by analyzing the traffic, and then we can surface the recommendation to our security team. So how this Defender for API works? Basically, by just enabling by just one click in the, for example, in the Azure portal, we can transparently mirror all the traffic to the Defender for API backend. So you can imagine over there the request is flying through the API management, reaching the backend, and then in the middle, the traffic is forwarded. So request, the body, the headers, the context of this call is forwarded to the Defender for API backend. Same way on the channel back, when we receive the response, that response is logged, is forwarded to the Defender API. So the Defender can implement that API security postures checks, but it can also implement that advanced threat protection, meaning using a machine learning-based detection to continuously assess if the workload, if our traffic is protected, is secure, and this advanced threat protection implement checks towards the OWASP API top 10 threat. So let's go to a little bit more in details and see what we learn by using this tool. So let's make it practical. So, but first, how to enable it? Very simple. You go on the Defender, on your environment, and you can enable the Defender plan by just flagging it to on. Then you have to search in the recommendation your API management instances. You can enable one or more instances, and within that instances, you can decide which kind of APIs you want to onboard, one or more, depending where you want to focus your analysis. And then once the tool is onboarded, once your one or more API management instances are onboarded, you can then analyze and see the results that are surfaced. Now, let's see what we experience, our experience with the tool. So we just enabled the tool on one of our, on this scenario. So we enabled the tool for 7 weeks, but here we are looking at the traffic, monthly traffic. So we observe more than 400 million calls per month, meaning 1,600 calls per second when we have the peak, because the traffic is really depending hours by hours, so less out of the business hours. We had traffic for more than 60 countries, and we had around 5 million distinct IP addresses. That's just to give you the idea of the kind of traffic. What did we learn? One of the things is like very important is about security posture, is to classify our workload. If you look at this research, this Palo Alto report, 94% of organizations believe that it's critical to understand which APIs are exposing sensitive data and which not. In this case, Defender for API creates a list of endpoints. categorize, identify which endpoint is secured with authentication, which not, and then here you see on the right some example of classification. Suppose that you have you are exposing some specific personal information in a non-authenticated endpoint. That's let's say very bad. Is something that you really have to take action first. And then also by understanding the data classification, you can first understand is it this critical? Was it this intentional to expose this information? Yes or no? In our case, everything was as it should. So we were very happy to analyze our traffic, classify your traffic, but also see that was according to our expectation. Another things that the defender does is to check security misconfiguration. The second most common OWASP top 10 attack is because of misconfigured API. In this case, the defender goes and check your Azure API management and surface some security, does some security check and come back to you with some security assessment. Here you see on the right the kind of check, an example of checks that are done. In our case, we were compliant, let's say, with 90% of the check. One of the things that we added thanks to this assessment was the minimum version of API management, which I believe is a very good practice. Then we move on with something like more threat protection, meaning machine learning based control. In this case, we detected a spike of API requests to a single endpoint. So we move, for example, from 70 call every 20 minutes. That is really nothing. At a certain point in time, it has been detected to a traffic of 865 per 20 minutes, which is also not so much for our traffic. But yeah, it was this alert was surfaced. So we analyzed it and we realized that in this case was a legitimate traffic because in that period of time we enabled a specific promotion and then some accounts were updated to get that promotion. But in general, this kind of scenario, it helps us to find if there are some broken user level authentication or there is some lacking in a rate limiting on a specific operation or on some specific operation plus consumers and other kind of throttling key. Another example was in this case is the enumeration through a parameters. So a specific parameter was called normally on average 1,000 times per 20 minutes, and it moved to 20,000, which is huge. But in this case also was in our example, it was a legitimate traffic. Why? Because you can imagine this was a sort of it's a path parameter, right? So you can imagine that it was a sort of session parameter. So a session in that amount of time, I mean, during that event, that promotion, more users were accessing to the platform, more users were interacting, and more distinct session was created. But the same kind of detection for other type of parameters would be quite critical signal, quite critical security issues that could lead to some broken object level authentication. Another example of insight that we can have with Defender for API is the one that are powered by the Microsoft Threat Intelligence. In this case, it can surface IP that has been associated with some malicious activities. And in this case, you could we react by going in and analyzing this high-level, high suspected IP addresses and decide whether to implement additional throttling on this. Let's say that also this kind of threat is even more important if it's combined with a suspicious spike coming from that IP that is marked as red. So we combine the threat intelligence with the machine learning to fine-tune our action, our workflow, security workflow that are coming later. So there are different multiple scenarios that are surfaced by Defender for APIs. Here you can see a list, but there is more. We just only saw a few of them. Now, if you look at the business model, how much does it cost, or at least how much it was costing for us? In our case, here is the business model is you pay per pack per month, and plus you pay for average per transaction. In our case, we were having 400 million, so we pay $7,000 for the first 100 million call, and then other $7,000 for every million call. So a total per month of $28,000. So quite a price, but okay, it all depends on the benefit that the tool brings to you. One more thing is about GDPR. So I'm based in Europe. Our customers are mainly European based. So over there, all the data that is moved to the backend of Defender for API stays in your geographical boundary. So in Europe, so IP address are retained for 30 days, but all the bodies only for 48 hours. So Defender for API also does honor the GDPR requirements, so you can export, ask to export the request for the data that are retained more than 48 hours, in this case, only IP address. And nothing of personal data is retained for more than 48 hours, so everything is, let's say, under control for GDPR point of view. With this one, it's everything for today. So thank you for following this session. Have a nice day.
Thanks, Massimo. I can't believe you packed in 3 sessions today. And of course, don't forget, if you miss any of them, you can subscribe. We're putting up the videos after the conference as well. So subscribe and get notified every time we put up those brand new videos, not only from APIs in Action, but all sorts of Azure goodies. All right, next up is Dave talking about how to gain understanding of APIs and integrations with Azure Application Insights. Over to you, Dave.
Hello. So my name is Dave Phelps, and I am a cloud solution architect at Microsoft based out of the UK. And I'm going to be talking to you about understanding APIs with Azure Application Insights. So I'll talk about a little bit about Application Insights, an overview, what Application Insights is, how to configure Azure API Management for Application Insights, then jump into a demo of App Insights, look at dashboards, workbooks, availability testing, and finally, alerting. So most of this presentation is actually demos. So what is Application Insights? Well, it's a way of being able to track and log how your application is running. And we can track application data, we can track business data, for example, an order ID, so that we could make the job easier for support to understand what's happened to an order at a retail company, for example. Application Insights also has built-in support for end-to-end correlation. So what this means is that when a request is sent from a website, for example, or a browser, that request would be sent to an API. The API might then call some kind of backend. It could be an Azure function, Logic App, or something different. Maybe that drops onto a queue, which is picked up by another process. And in the world of microservices, it can be quite tricky sometimes to understand what that journey looks like from a runtime perspective. Application Insights makes it very straightforward to understand what your application looks like at runtime. We also have availability tests, so we can run some tests to verify that your APIs are actually functioning, and we'll drill into that in a demo later. And finally, we can look at exceptions and performance, so understanding why my application may have failed and where it failed. So let's jump into some demos. So the very first demo that I'm going to show you is application map. An application map is that runtime aspect that I was just talking about. And here is application map, and you can see that there are a whole bunch of different components here. I'm just going to zoom in so that you can see what's actually going on here. It's a bit tricky on this screen. It doesn't actually matter too much, but you can see here I've got my API management instance, which is shown here, and I've got two clients that are calling my API or calling an API on API management. So I've got my availability test that we'll look at later, and I've also got another client. So if you have multiple clients calling your API, that will get reflected in application map. We can then see that my API management instance is calling into this is actually a logic app. The logic app is then talking to a SQL database. It's dropping a message onto a queue. That is then being picked up by a function app. The function app is then dropping onto another queue and hitting these other two function apps here. So if I just zoom out for a second, just so you can see the end-to-end flow, this is particularly useful in understanding what my application actually looks like at runtime. But I can actually do some other things here. So I can see that there's a little red here, which shows that I've had some failures. And this is on the API call in API management. So if I click on this, we can see up here that we've got some failures. So I can click on investigate failures. And then it comes here and it's showing me a graphical representation of, for the different requests, how many failures I've had. You can see I've got some 502s here, so I could click on that. And App Insight is automatically suggesting an end-to-end of a particular trace that's failed. So if I click on this, then we get this end-to-end view. It's a bit, if I do that, then we can see that we've got the availability test, which made the call into API management, which made a backend call, which called into my logic app. And finally, down here, we can see that I'm executing a SQL, using a SQL action in logic apps. And then we've got this red item here. And if I click on this, you can see the exception details, and it's saying could not find store procedure, create customer 2. And I manufactured this earlier on to force it to fail. And I can click on show more, and we can actually get the entire stack trace. So you can see this is particularly useful with your applications in production, where if you see a failure, you can drill right into the detail, right down to the exception that caused the failure in the first place. So if we go back to application map, we've also got this failures tab here, which does a similar thing where I can drill into those details that you just saw from application map. We've got performance as well, so we can then see how our APIs and also all of the backends are performing. So here's my API. I can click on that. I can then drill into the details, so I can see the call times of my API, but also, more importantly, not just the API itself, but all of the dependencies. So I can really get a feel for how my API is performing, because of course it's not just about the API. The services on the back end of that API are obviously really important, because they're the things that are adding up the different call times that goes back to the client, and if it's an HTTP call. So I've shown you what application insights looks like at a high level. How do I configure that inside API management? And I just need to pause here for a second. I'm not quite sure what went wrong there. So I'm going to have. So here I am inside API management, and this is where I can configure application insights. So I can click add, and it's going to give me a list of the different application insights instances that I have configured in my subscription. And you'll notice here we have this add availability monitor tick box. If I tick this, then API management is going to configure application insights to go and hit my API management service to validate that it's actually up and running. And we'll see that in a second. But once you've added an application insights instance into APIM, we can then go to individual APIs. For example, my Contoso orders API here. And we can click on settings, and we can then select the application insights instance that we want to use. And this is particularly useful because if your API management service is being shared amongst multiple teams, then each team may want to have a different application insights instance, so they can have control of it. And it may be that the data that is being recorded there should only be seen by certain people controlled through role-based access control. So once I've configured my application insights, I can then go and configure some other settings. So I mentioned about the correlation earlier on. This is what helps API management send a correlation token to the back-end service, which is what adds to that application map that you saw earlier on. I can log the payload. So we need to be careful doing this because depending on the payload size, this could have an impact on performance. But nevertheless, if we log the payload, then that becomes useful from a query perspective, being able to pull out certain pieces of data like the order ID that I mentioned earlier on. But of course, it's not just about API management. The back end, there could be, for example, a function app. The function app could also be tracking some custom data that might be useful to us. So that's how we configure application insights in API management. And we've seen the basic overview of application insights with the application map, exceptions, performance, etc. But we can also navigate into the logs. And so I've got a very simple query here, but if I run this, it's going to show me how many failures I've had and how many successes I've had, because application insights is writing this telemetry into a bunch of different tables that you can see on the left here. So there's a request table, we have exceptions and dependencies, which allow us to query those tables and create some custom queries. So at its most basic level, if I just run a query here, then these are the items that come back. And we can see my API management call here, the logic app actions. I can drill down into in fact, if I just go back 1 second and I go and pick an operation ID here. Operation ID being the one value that will correlate across all of the different API calls. So in my case, I've got my availability check. This is my client, goes to APIM, which goes to a logic app. The logic app executes a bunch of actions, which then goes to the 3 function apps I spoke about. So we could also query on some business data. So in my case, I'm logging the request body, but I could, using logic apps or functions, I could just write out the product name, which would be more efficient. but just for demo purposes, I'm showing how I can pull out the product, and then we can see how many orders have been received for each different type of product. Now, I mentioned that this particular process involves a bunch of function apps. It involves a logic app. It involves API management. So what we can do is create another query that allows me to pull out the product name, an order ID, the name of the person that placed the order received, and crucially, when it completed, because this completed time is actually the time when the final function app executed successfully. So what I'm doing here is actually showing the time that the order hit API management right through to the time that the order completed in my backend process. So I could also do something like this, where I can query and understand who is making calls to my API. Now, these email addresses are the email addresses of API users. So they could be people who own an app or a website, for example. And all I'm doing here is pulling back the email address. And I could use this for cross-charging, or I could use it for billing purposes. And if I just show you very quickly, this is my API management instance, and this is my API. And I'm using a trace policy to just write out the details of the user that has made the call to the API. And by that, I mean the person who owns the API key, the person who has built an app or website. And so what API management does at runtime is it does a lookup on the API key to pick up the context of that API call. And I'm just pulling out email address, first name, last name, so I can then go and use that in my queries. So once I've written the query, I can then save this to a dashboard, so that that dashboard could then be saved and it could be shared with other people. And I can do that by just clicking Pin to Azure Dashboard. And I've already pinned a few of these. And if I go to my API Day dashboard, then I can turn auto refresh to on. So here are this is the number of calls that people are making. I have my products, and over here I have my analytics. So this would be particularly useful to give to someone in support, for example, so that they can see what's going on. Maybe someone in the business might be quite interested in some of this information. So that's fine, and we can create these visuals, but wouldn't it be even better if we could create visuals that were a lot more targeted to the people that want to monitor the APIs? And this is where workbooks come in. So I've created a workbook here that allows me to search on an order ID. And the default view I get here, if you recall, this, the information we have in App Insights is actually quite technical, but I've pulled out a bunch of information like when the order was received, when it was completed, the customer name, the order ID. So if a customer were to phone up and say, hey, I haven't received my order and my order ID number is this, then I can just do a search and I can find my order. I can click on that order, and it's actually off the bottom here, but you can then see that we can drill down. So I can then do a drill down into a specific order, and I can see that the order was received. I can see all of the actions that took place. And then what I can do is, if there is a failure, I could drill down into that even further in order to understand any kind of exceptions that I may have had. And if I just click edit on this workbook, you can see that I've just added these visuals. I've added an order ID field. I've got this query here, where all I've done is just written a query that is pulling back the information that I'd like. And these are incredibly flexible, and I think they're particularly useful for support departments, so that you can search on keys or data items that are actually really relevant. And it means that people don't need to go and learn these custo queries that are in the logs. They can just have access to a workbook and get the information important to them. The final two things I wanted to show, firstly, is availability. So way back a few minutes ago, when I showed configuring one of the application insights instances, I ticked the box about availability. And you can see here that we have my APIM instance, and I've got a very successful set of calls here. This is just checking that API management is up and running. But what I've also done is I've created a custom availability test, because my API could actually be on a private network, or it could be protected with OAuth, like mine is. I'm doing a validate JWT here. And the default tests that you can create here through the portal, they don't give you that flexibility. You can't be on a private network or using kind of more complex security protocols like OAuth. But using the App Insights SDK, which is pretty straightforward to use, and I'll share details on how to do this, we can create our own custom test. And I did this just with an Azure function on a timer that's hitting my API, and it's actually fetching a token in order to pass that validation test that we saw. So we can see that I've got some successes, I've got some failures. And if I just click on my failures, I can do the same thing I did before. And then I get my end-to-end trace, and I should be able to navigate down to, there it is. And it's actually the same error, my contrived create to store procedure. So what's cool about this is that you can actually have availability tests that are actually testing the API itself by fetching a token. It can be on a private network. And if there's a failure, then we can just drill straight down into the individual error to understand what's going on. So that's availability testing. And the very final thing I want to show are alerts. So I've created an alert here. We click on alert rules, which is called alert if not complete in 5 minutes. So I will just click on edit, click on condition, and I've written a query here that is actually calculating the amount of time that it took for the order to be completed. So if, for example, my order didn't complete for some reason, then what I'd like to do is to generate an alert for somebody to be able to be notified that this hasn't actually completed. And my check here is for if the time taken is more than 300 seconds or 5 minutes. So you can see that it's actually incredibly easy to be able to create an alert that is going to notify somebody in the business, for example, that there's a problem, or it could be somebody in support, so that they can then take action to understand what's going on. But of course, the alerts don't have to be just about how long it took to complete. It could be that we're alerting on some of the business data, or possibly the number of failures that we've had over a particular time period. And so once I've created my alert, I can then configure who an email goes to, or it could even be a webhook, or I could trigger some other process to take some kind of action. And I think that is the end of my presentation. Thank you very much.
We're learning so much and gaining so much insight. Thank you, Dave, for that. Next up, we have GitOps and API Management with Terraform with Christine and Maxi. Take it away.
Hi, welcome to our session, GitOps for API Management. I'm Christine Robinson, and this is Maxi Ott. Today we want to tell you about our experience developing and deploying API management for a large company, and hopefully give you a few insights and inspiration for how you could adapt this in your organization. First, a few words about us and where we work. So we're both senior consultants at Objektkultur Software, a German consulting and software development firm whose passion is understanding the needs of customers and being able to deliver added value as quickly as possible. As a Microsoft solution partner, our consultants have special expertise in Microsoft products. So I originally trained in mathematics in the US and made the shift to IT when I moved with my family to Germany, and then joined Objektkultur in 2021. Since then, I've been involved in a number of projects with a focus in integration, automation, and infrastructure as code. So enough about me. Maxi?
Yeah, hi from my side. As Christine said, I'm a senior consultant at Objektkultur too. I started as a working student during my studies in 2018, and I focused on technologies such as Azure Integration Services, Dynamics 365, and data analytics tools.
Great. So now onto the interesting part. We've been part of a team based in a large international corporation that has hundreds of applications with a wide range of internal and customer-facing business needs. And as part of a digitalization and API-first strategy, they made the decision to introduce Azure API Management. And our team was tasked with planning, introducing, and maintaining this for the company. So, of course, we had requirements that are unique to this organization, but in general, they're fairly universal. So first requirement, speed. We want to be able to bring new features into production quickly, and we want our API developers to be able to publish and change their APIs quickly. This means that our processes need to fit into the tools and workflows that the developers are already familiar with. Security. The company exists in a complex regulatory environment. It's located in the EU. It's in a high compliance and governance industry, and there's strict standards around access to data and systems. So we need to ensure that access is appropriately restricted at the right times while still allowing for rapid development, and that all the changes get documented according to company requirements. Finally, scalability. We want to support growing complexity and growing numbers of API providers without compromising our other two requirements of speed and security. So these requirements led us to opt for a centralized setup. And as you'll see, this allows us to enforce uniformity, ensure compliance with regulatory requirements, and support a natural workflow for our developers. And Maxi will show us what this looks like now.
Right. With these priorities in mind, we developed a GitOps approach for developing and maintaining API management as a shared service for the company. This means for us everything as code, in short. And in this high-level diagram, we can see the main components and participants in our solution. We will look more closely at the different aspects of this in the coming minutes, but first let me explain the big picture. In the middle, you can see the main Azure resources, the API management service, the APIs themselves, the developer portal, and the API linter. And both the API developers on the left side and the API consumers on the bottom are customers of our platform, of our shared platform, and uses the Azure resources. And finally, the shared service team on the right side, we will focus first on that team and how we implemented this everything as code approach in this team. So starting on the bottom, about the main infrastructure, we implemented everything as code with Terraform and Azure DevOps YAML pipelines. The main components are the API management service, many network resources, scale sets as build agents, which are running our pipelines inside the network, and some other Azure resources that aren't that relevant for us today. And we have 4 stages. sandbox, dev, test, and production. And from the perspective of the shared service team, the developer stage is our first productive stage. This is the mostly used stage by the API developers, and every time the shared service team has to test something on the API management or the test changes, we use the sandbox environment for that. So the API management users aren't impacted from our testings and changes. So next we have the API linter service, which helps us and the developers to satisfy the company-wide rules regarding governance, security, naming conventions, and so on. And for that, we pinch the open source Zalando rules and customize them for the company. These customized rules are stored in a repository and must be provided for the API developers. And for checking the open API definitions, Zalando provides an open source online editor. And we use this online editor, deployed it to Azure, running on an Azure app service, and linked it to the developer portal. So the developer portal is already used by the developers, and they can see the online editor and the rules in the portal. So next slide, here we can see the online editor. We can paste the open API definition on the left side, validate it, and see on the middle, see the violated rules. Some short description about the rule, and by clicking on the rule, we can see the whole description from the rule and helpful examples for the open API definition. So it should be as easy as possible for the API developers to fix their open API definition, and no violations are inside the open API definition. And this tool is simple but very helpful for the company to roll out the rules for every API that is deployed in the platform. Christine will show us later how the team can make the rules obligatory for each API. So back to the whole picture. There is one more box from the shared service team, the API repository template. In this, we have templates for all Azure resources, the Azure resources we deploy for the API developers. This is the base for every API developer team, including an API repository and some pipelines. In this space, the developers have as much freedom as possible. Here's their open API definition stored. There's a policy file for API management policy configuration and the two pipelines, one for pull request checks and one for deployments. And now let's have a look into this and how the developer workflow looks like.
Great. So now we're looking from the perspective of a single API provider team. So when a team wants to make revisions to their API or to their API policy, again, we want to fit in with the normal development workflow, create a branch, make changes, open a pull request. But then we have some required checks on the provider pull requests that have to be passed in order to merge the code to main. So one is a pipeline that validates the API specification against the linter that Maxi just described. So the feedback is written as a comment in the pull request, listing any rules that are violated by the open API definition. And the pull request cannot be completed as long as there are violations of must rules. If there are violations of should or may rules, we tolerate those, but the developer has to manually resolve the comment in the pull request, which guarantees that they've seen those and accepted them. So once those checks are successful, a second developer can review and approve the pull request. The pull request is completed and the code is merged to main like normal. This then triggers another part of our security process, a release pipeline, which, among other things, documents the infrastructure change in ServiceNow. So our organization requires that all infrastructure changes have to be centrally documented. So we do this automatically via a pipeline. This could be in your setup replaced with any other sort of centralized change management system to ensure transparency. And then finally, the changed API is now deployed to API management following successful health check of the endpoints. And now the API can be used, tried out in the developer portal. It's available in the API management service. So with that, we have a process that brings APIs to production that fits right in with the usual workflow of the developers while enforcing compliance with organization and industry standards. Okay, this raises the question, who is allowed to do all these things? Who can make changes in the developer repository, make pull requests, etc.? So we need a good permissions management concept. And here we follow the principle of least privilege, or as much as necessary, as little as possible. So as far as the developer workflow goes, each developer team gets a dedicated Entra ID group and DevOps security group, through which access to Azure resources like monitoring workbooks or access to DevOps resources is controlled by role-based access control.
Let's turn again the light on. Okay.
Okay, I'll start over at that spot. So as far as the developer workflow goes, each developer team gets a dedicated Entra ID group and DevOps security group. API-specific resources like monitoring workbooks are granted via role-based access control only to members of that Entra ID group. And within Azure DevOps, only members of the DevOps security group get permissions to merge changes in the provider repository, approve pull requests, start pipelines, etc. Moreover, the API provider, not our shared service team, is the owner of its own group. So we create the group, but they're responsible for managing the membership. A designated owner and approver has to approve any request for membership. In this way, the security of their own resources remains the responsibility of the resource owners, but it's enforced and centrally technically rolled out by our team. Now, of course, other processes and workflows also require a permissions management concept. So I'll give you just one example here. Onboarding new API consumers. Can anyone just consume an API? No, by default, everything is locked down. If someone wants to consume a new API, they have to get approval from the owner of the provider and then enter a service request in ServiceNow to get access. This then triggers a pipeline through which the subscription key is issued and access is granted to the managed identity listed in the request. And then naturally, following our everything as code approach, we define those roles and manage the assignments in Terraform code and deploy them via our release pipelines. Okay, so we've told you how we set up and how we maintain API management as a shared service. Now a few numbers to indicate how it's been adopted by the company. So we have more than 150 users actively contributing in our DevOps project with over 1,000 commits in the last month. We manage 4 stages, as Maxi mentioned, 3 of which are used by our customers, and in 2 Azure locations. And we have about 20,000 calls per day made to 70 APIs from more than 50 consumers. If 50 and 70 doesn't sound like a lot at first glance, consider that over the 3 stages in 2 locations, that means there are up to 20,000 connections between providers and consumers, all managed centrally on the platform, which highlights some key benefits for an organization. Everything is centrally cataloged in the developer portal. All these APIs and connections are guaranteed to satisfy standards and security rules. There's a high level of transparency and traceability regarding which data is being consumed by whom. And finally, everything is centrally documented and connections can be suspended one at a time if needed. And then all of this is developed and maintained by a small core team.
Yeah, and finally, we want to point out that although our use case was for a large organization, you can adapt the pattern for small or mid-sized companies. All the advantages that Christine just mentioned hold just as true. Moreover, the same pattern can be implemented with a different tool stack. For example, use Bicep instead of Terraform for infrastructure, or use Jenkins instead of Azure DevOps pipelines for CI/CD. So before we wrap up, we want to leave you with a few interesting links. One of them is APIOps repository from Microsoft. This is very similar to our solution and fits if you only need API management as an organized platform service. So in our case, we use the same pattern for service bus and eventing services to provide a complete organized integration platform for our customers, and added some extra functionality like the API linter. So second one is a blog post from my colleague about designing API first with TypeSpec. And if you or your company needs more input and enablement to set up the API management service or one other integration service, you can get more information via our cloud integration page or contact us for support. So that's our experience with deploying API management with a GitOps approach. We hope that we are able to provide you with some insights and inspiration for how this could look like in your organization. So thanks for your time and attention. If you have any questions or feedback, please feel free to reach out to us.
We're almost done here in APIs in Action Day. However, we have one more awesome session coming your way from Weil, talking about all the ops, API ops, and how to transform Azure APIM deployments with GitOps and DevOps methodologies. Take it away.
All right. Welcome everyone to today's session about API ops and transforming Azure APIM deployments with GitOps and DevOps methodology. My name is Wael Kadu. I am a principal cloud solution architect here at Microsoft. I will be your presenter for today. Just want to go ahead and mention some of my colleagues who are the co-creators of the API ops tool, which will be the topic of today's discussion. I have Rishabh Saha, who's also an architect here at Microsoft, Guy Fenkham, who's also a colleague here, a cloud solution architect, as well as Srini Padala, who's also a cloud solution architect. So for today's session, as I mentioned, we're really going to be focusing on API ops as your go-to tool for everything Azure APIM DevOps. And before I kind of jump into the details of how the tool works, I'll also be kind of demoing, doing an end-to-end demo later on. So you definitely want to stay tuned to the end of the session, where we will basically take all the theory and kind of show you the practical usage of all these great ideas that we actually introduce as part of API ops. So one of the things that I always think about API ops is we really need to talk about, whenever we talk about API ops, we essentially need to understand how to apply the concept of DevOps and GitOps to the APIM lifecycle. But before we dive into that, it's important to understand how does the adoption of APIM impacts DevOps or DevOps. So I love this meme here that we're looking at on the screen, because in a sense it really applies to all of us. And, typically as an API developer, whenever you're using, Azure APIM as a product, more often than not, you are the API developer. And you're typically excited about creating APIs, but whenever we hand it to the DevOps team, this is where typically things start to become a bit tricky, because at this point, really, do you know for sure whether it will work or not? So you typically just go ahead and say, I hope, or even pray that it will just work. And as we all know, more often than not, it doesn't really work without a solid DevOps process in place. So when introducing new API designs, the impact of DevOps engineer is often forgotten, right? The impact on these engineers is really often forgotten. And this is where if our feature teams or your server tier developers are experimenting with the solutions, unless your DevOps process is formalized, it's normal to be prone to failures in production if DevOps cannot successfully deploy them. So within the context of Azure APIM, the impact on the DevOps engineer is often forgotten, right? And I'd like to kind of repeat that, because you typically care about, hey, am I creating an API on Azure APIM if you're using your portal or your Azure CLI? And then you kind of really forget that this has to actually be automated at one point. So this is the beauty of what API apps is all about, is to actually have that process in place from the get-go, so that later on, whether it's your operator or your API developer, they will have some kind of tool, right, and process in place for them to actually utilize and kind of self-serve. So one of the reasons why we combine the concept of GitOps, which is typically mainly around using Git as the source of truth, with Azure APIM, is because all the components that you deploy within Azure APIM have a declarative approach, right? So say, for example, you are creating an API specification, those can be created declaratively, or say, for example, you are creating some service level information like logging or monitoring, diagnostics. All these can also be created declaratively. Typically, it's a combination of JSON and YAML files, which again we will demonstrate later on once we look at some of the demos. So let's kind of, double click a little bit into the what, right? So as you can probably tell from the title of the talk, API Ops applies the concepts of GitOps and DevOps to API deployment. So the idea there, when we first envisioned the tool, was that by using practices from these two methodologies, API Ops can enable everyone involved in the lifecycle of API design, development, and deployment with self-service and automated tools. This basically ensures the quality of specifications and the APIs that they're typically building. And the beauty of having such tools in place is that, in addition to obviously introducing a solid DevOps process, and automation, it also allows you to kind of ensure better quality as well as speed due to obviously this level of automation that we're enabling with API Ops. Now, some considerations, that, we had in mind when we were designing API Ops are mainly around design and testing, deployment, as well as maintenance. So the idea there is that we wanted to enable the different personas that are typically involved in an Azure APIM deployment. So that's your operators. Usually these are, the folks who are responsible for service level, artifacts. Again, we kind of mentioned them earlier, things like logging, diagnostics, maybe global policies and things like that. But also we have our API developers. Obviously, these are the folks kind of doing the day-to-day deployments, modifications, and maybe introductions of new APIs. These are folks that typically would spend more time around open API specs or maybe API level policies and things like that. So we want to kind of enable these, folks, and these are kind of the main targets to our API Ops tool, mainly being the operators as well as the API developers. So by giving them, a tool like API Ops, the goal there is that from the get-go, they will have a clear process on how to kind of self-serve in terms of designing these APIs or global assets, and then testing them, and then also automating their deployment, and later on obviously maintaining them, right? Kind of saying that, hey, we have things that already exist, for instance, on an APIM instance. I would like to go ahead and maybe modify it and then push more changes against the live instance, which again we will demonstrate later on once we take a look at the demo. So again, let's double click on some of these ideas there. So in terms of the design, testing, and deployment, again, because GitOps is at the heart of everything that we did with API Ops, it all starts, obviously with having a source control, Git source control. That's going to be your source of truth. And then you as a developer, say, for instance, you're sitting inside your favorite IDE. That could be, for example, something like VS Code. You're working with specific, maybe API specifications, like your OpenAPI specification, or even, if you're an operator, you could, for instance, be working with a policy. There are certain extensions, for instance, in IDEs like VS Code, which even allows you, for instance, to debug some of these policies, make sure they're, working fine. And once you're ready, you would go ahead and, again, use the usual commit and push with Git. And that allows you to kind of trigger that whole pipeline or process, within your DevOps environment in order to kind of take these designs and actually push them against your live APIM instance. Again, when I say live, I'm not necessarily talking about, production only. Obviously, you can have multiple live instances, some of them, with purposes of doing some, testing or QA, and then obviously production, which is exactly what we encourage with API Ops, to have these multiple environments. And then that's the beauty of API Ops, because it allows you to kind of promote these changes as you go from one environment to another really easily because of this level of automation, which again, I will be demonstrating shortly, so you can have a better understanding of how actually all that works. In addition to the design, testing, and deployment, also we enable another scenario, which we like to kind of refer to as the maintenance, and that is we support the extraction aspect. So what I really showed you there in the previous slide, you can think about it as the publishing aspect. That's, in a sense, if you think about API Ops, it's really a combination of two binaries, for lack of better terms. One of them is really the extractor and the other is the publisher. Now you could use the publisher only, which is what I just discussed in the previous slide, and that is the idea of just simply saying, I'm going to go ahead and develop in some kind of IDE. I do a git push. That git push typically initiates the creation of some kind of PR. And then once you merge that PR, after you're reviewing it, maybe just making sure everything looks right, that can trigger a deployment against your APIM instance. So you could, for example, just set up a DevOps process, which constitutes just the publishing aspect. But a lot of times we see a lot of our customers, what they do is they typically like, for example, to start with an existing APIM instance and then extract any artifacts in that APIM instance and then promote these changes to higher environments, while maybe slightly changing some of the configurations, say, for instance, pointing to a different backend API, or maybe, having different named value pairs, or, things that would kind of differ across environments. So we enable that scenario as well, and this is covered by what we like to call the extractor inside API Ops. So it's the best thing to kind of think about, API Ops, just it's two different binaries or processes. One of them is for the extraction and the other one is for publishing. Now, if you use the extraction, obviously it will involve the publishing at one point, because whatever you extract, you need to publish it later on. But the publishing aspect does not require the extractor to be involved, because like I said earlier, you could just, for example, start from scratch from within your IDE, you push your changes, commit your changes to your Git repo, and then just trigger the publishing. We have all that heavily documented, on our main repos. Again, I'll be showing you later on, some really good starting points where to kind of start with API Ops, and some links to the documentation, which really explains all these aspects in details. So let's kind of take a look here at an end-to-end. If you look at this image here, notice we have a couple of things that are involved. Obviously, the APIM instance itself. We also have the different personas. We have your API developers and then your operators. So your operators, typically, these are the folks who are responsible for, service level assets, things like agnostics, logging, global policies, and then your API developers who are really working against specific APIs. Typically, you have, scenarios where maybe same API developers are working against all the APIs in the APIM instance, but you may have different scenarios where you may have different developers working on different APIs. Obviously, at the time of this session, Workspaces is currently in public preview. There is some work to actually eventually bring support for Workspaces into API Ops. And you can actually check that out on our roadmap within our GitHub repo for the API Ops project. So rest assured, if you're somebody today kind of looking at Workspaces, under Azure APIM, and you're like, will API Ops ever support that? The answer is yes. But again, at the time of delivering this session, when you're watching it right now, Workspaces has not been fully implemented yet. So just something to keep in mind. So we do have some kind of workarounds. Again, you will find it in the documentation where we kind of we have some recommendations on how to kind of emulate the support for multiple API teams with API Ops. So you can kind of read that on your own. But rest assured, in the future, we will bring support for Workspaces. So as you can see here, if you look at the extraction aspect of it, it allows you to run a pipeline, which actually extracts from the Azure APIM instance. And this extraction typically triggers creation of a PR. And then that PR, after it gets reviewed and approved, it will actually trigger the, and it gets merged into the main branch. It actually triggers the publisher pipeline, which goes ahead and publishes these changes back to the APIM instance. Now, this image doesn't really capture the full story, because in reality, when you publish, you don't have to really publish back to the same APIM instance. More often than not, let's be real here, your intent is really going to be to take anything that you've maybe extracted and kind of promote it to a higher environment. This image really mainly captures the scenario where you're probably working inside an IDE and you made some changes and you want to go ahead and publish it to the specific APIM instance. Typically, it's your lower environment, but just understand that you can also publish to higher environments. And we actually even have a full configuration system inside API Ops, which allows you to kind of override values as you're promoting these changes from one environment to another. You know what? Let's go ahead and do this. Why don't we go ahead and switch to the demo here? I would like to kind of show you how to demo all this in action. So in order to do that, I set up here an Azure DevOps environment. Now, I do want to be clear. I am demonstrating user Azure DevOps, for the purposes of this demo. But by all means, feel free to, host all this inside a GitHub repo. As a matter of fact, let me switch really quickly. I want to show you kind of the main repository where we host all this. So this is going to be on github.com/Azure/API-Ops. And you will notice in here, we do actually have a link to the documentation. So if you follow the documentation, we kind of demonstrate everything, from the extraction to the publishing, using both GitHub as well as Azure DevOps. Now, I have received in the past some questions. Some people may say, okay, well, you are actually demonstrating using Microsoft DevOps tools, mainly being Azure DevOps and GitHub. But what if we're using un-Microsoft tools, right? So just as an example, maybe you're using Jenkins or something else. We do offer the pipelines only for Azure DevOps and GitHub out of the box, but that doesn't mean you can take these pipelines and adapt them to your own environment, right? So for example, you could use something like Microsoft Copilot and say, hey, Microsoft Copilot, take these pipelines and convert them to me to Jenkins pipelines. Right? At the end of the day, really what these pipelines that we're providing you with, you can think about them as turnkey solutions so that you don't have to take our extractor and publisher binaries and kind of figure out how do I start integrating these within some DevOps pipelines. So the best way to think about API Ops is the combination of the binary, which are the two binaries, which are the extractor and publisher, and then the set of DevOps pipeline. And these are two independent components. For the most part, I would say 99%, the extractor and publisher are really oblivious to the DevOps environment within which they're running. And I say 99%, again, as you go through the documentation, you will notice there are a couple extensions that we have to install in Azure DevOps and GitHub, mainly being the replace token extension. But aside from that, everything is self-contained in the extractor and publisher. As a matter of fact, you can take these extractors and publishers and run them local on your machine if you want. They're just two .NET applications, .NET applications built in C#, right? If you really wanted to kind of know the details. So out of the box, yes, we are only providing you with the GitHub and Azure DevOps pipelines. But by no means this means that you are restricted to these, right? And you can kind of find them here. Again, once you go into the releases, you will notice, again, it's a good idea to always kind of, maybe follow our releases on GitHub so you get notified whenever a new release gets pushed. So for example, if you take a look here, you'll notice some of the assets that we provide you. You'll notice we have the DevOps pipelines as well as the GitHub pipelines. So feel free to take these. If you want to adapt them, say, to your Jenkins, just go ahead and adapt them. We just offer these two out of the box, which are Azure DevOps as well as GitHub. All right, so let's go back to kind of showing you the demo here. So as you can see here, typically, just to kind of start from scratch, I'm going to go ahead and delete these artifacts. So let me do one thing here because I know this is going to trigger my pipeline. Let me cancel the run here for a second because I want to show you everything running from scratch. All right, so let's go ahead and cancel this one. Okay, perfect. So if you go back and look at the repo, typically you don't have any artifacts. So I'm going to show you the scenario where you want to start with an existing APIM instance. So if I show you here on my Azure, portal, notice I have a resource group which includes what constitutes the lower environment. So I'm going to go ahead and show you some of the APIs here which I would like to promote to a higher environment, right? So these APIs have already been created. So I have a lot of these APIs. We have a bunch of name value pairs, some policy fragments, some API tags, some API level policies, as well as maybe some policies that will apply to all APIs. And if you look here, you will notice that I have another APIM instance, which is right now is empty, right? So I don't have any APIs. I don't have any of the named value pairs that I showed you earlier. This is just an empty APIM instance. And then I'm going to demonstrate here by using API Ops how we are able to actually go ahead and extract everything. So I'm going to start with the extractor pipeline here, and then we're going to look at the end-to-end process here where we go ahead and look at the artifacts being extracted. So while this is running, I just want to kind of talk about a couple of things that will happen here. So you will notice that we're going to go ahead and extract from the lower environment, which in this case, you can think about it as maybe the development environment. And then the artifacts are going to be extracted and a pull request is going to be created, right? As a good DevOps practice, it's not a good idea to kind of, extract and just go ahead and add it to the main branch. So we will notice that there is a PR that will get created. And once this PR gets created, what will happen is I'm going to go to that PR. Typically in a real life scenario, you would have a couple approvers for say, for the sake of time here and just for demoing purposes, I will be the only approver. So I will approve what I just extracted, but obviously in a production environment, you don't want to do that, right? At least have maybe 2 or 3 approvers. They would review your code, see the changes, make sure everything looks right. And then once you go ahead and approve that, you will merge. And at that point, once we go ahead and merge these changes to the main branch, and again, you could change that behavior, for example. At the end of the day, it's just a DevOps environment. It's up to you to kind of determine, how things will work for you. And, once the actual extraction is done, that PR is created, we merged. What you will notice there is that the publisher pipeline will actually be triggered. Now, this is where the beauty of this whole process is, right? So we extracted these artifacts just by running a single pipeline. And if you recall what I mentioned in the earlier slides, I said these actual artifacts are actually going to be all declarative. So that's the beauty, right? That we can go ahead and take these artifacts, run them through the publisher, and then it'll go ahead and publish all these changes for you to a higher environment using this end-to-end DevOps process while using automation. So that's really what it is in a nutshell. We will give it here another maybe minute just so that we wait for the extractor. By the way, you may have seen a slight error here while I was running just for the, for my demo, I had a step here, which is running a spectral linting. Again, I just didn't have all the spectral linting right. So just in case you're wondering, hey, wow, we saw a failure there, what's going on? Don't worry about it. Typically, you would make sure that in your case, you have the proper linting, which, by the way, it's really a nice step to make sure that whatever you're actually about to promote is indeed valid, for example, OpenAPI spec and whatnot. So we should see the pull request here. This is the active pull request. It just got created right now. We're going to go ahead. Again, typically you would have an approval process. Just for the sake of this demo, I'm going to go ahead and merge it automatically. So the beauty of that is you'll notice that all these artifacts just got created. And for you as a developer, this is amazing, right? Because this is what you as a developer kind of understand. So if you try to kind of map what you're seeing here, right, to what you see on the Azure portal, it's really easy to kind of map one-to-one. Like these are the APIs, the named values, so on and so forth. And if you kind of look deep in there, each one of these, assets are going to be just either JSON files or XML files, which is what we're going to be promoting. So if you look at the publisher, it got triggered here, which is great. Now, one thing you will notice in my environment, I highly recommend that you guys do the same, is we're going to go ahead and redeploy to that same environment from which we just extracted. May feel repetitive there, but the beauty of it is that it makes sure that you actually have all the checks and bounds, and then this way, by the time you go to production, you know that everything is exactly as it's supposed to look like. So once this completes right now, which is publishing to production, you will see all the APIs and all the named values, all the other assets, loggers, all that other good stuff, which was in the lower environment, all actually published into this higher environment. Now, remember, the extraction step is optional. I could have just easily, did all the coding in VS Code, checked in, trigger that publisher and just push directly to my APIM instance as well. So we are catering. You can think about it as for both greenfield or brownfield, or maybe people who always like to do things in the portal and then promote them to higher environment versus those who like to do in VS Code and maybe push and promote. We got it all covered. So hopefully this is fine. We'll go ahead and refresh here. If we go here into the APIs, there you go. Just like that, all the APIs are in there. So that was our demo here. That pretty much covers the end-to-end demonstration of how API Ops really works. All right, so thank you so much, everyone, for actually spending the time here with us. Hopefully you enjoyed this, and please make sure you check our GitHub repo, talk to us, communicate to us via GitHub issues, and we will be more than happy to address any questions that you may have there. Thank you so much for actually attending this session around API Ops and how the idea of GitHub and DevOps actually supports having a good DevOps story for your next Azure APIM deployment. Bye-bye, everyone.
Well, that is going to do it here for APIs in action.
Thanks so much for joining and watching with us today. We hope you learned a lot. I know I did. If you were unable to catch any of those sessions from today, don't worry. They're going to be uploaded on this YouTube, recorded and live shared for you. Thanks all for watching. See you next time.